rather than later, 100%.
It is
And
indicative of a huge flaw in our system, yes.
I think I might agree with you 100% on that. And in fact, there have been several bills that have been raised, and I think some passed to try to fix those flaws. For
excellent.
example,
This is an
sanctions against
improvement.
rogue election. Yeah, but
This is an improvement. And I think that if this was going to happen, this was a pretty good way for it to end up. You know what I'm saying? And in my bones, I honestly do not.
That the lessons have already been learned. So I don't know. It seems kind of contradictory in what you're saying.
No, I mean, I don't claim to not have an ego. But like I've gotten, like, I just think I'm kind of, my theory is that we all have like a certain amount of time that we have to spend here. So it's like equal in heaven, you know, like, why is he here? He only spent like 10,000 lifetimes, and I fucking did like the whole 100,000 that everyone else did. Like, I think that's really it. Cause I feel like I could be brought right back to, I could be brought up to the same, the same height as all the gods. And I think spirits are just malleable in that way, that like they just turn into God because they don't lack there's no limit, right? They don't lack a capability. They don't have to like grow like physical things, you know what I mean? So it's just magical. So I don't think, like, even though we're learning, it's like a process of learning. I don't really think like your spirit actually changes. Like, it might, but I think it's really just like a time thing. Like, we all need to spend as much time as ever.
You think? And I do appreciate, however, that you're very upset about what happened, and as am I. But I guess what I'm saying is I'm looking at this with a much more positive spin than you, and I think that the country's actually all the better for it. No credit to Trump.
well,
No credit to Trump.
I was going to say I would feel better about it if, following his attempt to overturn the election, people had, Republicans had said, that guy's done in politics. We can't have this asshole anymore.
I don't give a shit about any.
That is not what they said.
I do not care for what any political party would say in this matter, right? They are not the ones that would be in the position to, how would I phrase this? Regardless of how any political party feels or acts towards Trump, this is still a net positive. No credit to Trump. I'm going to say it again. No credit to that man. But honestly, while many of my colleagues in the university were saying, "Oh, this was horrible. Oh, this was horrible," I just had a very different outlook of it. That this was positive. This showed that our system can work. It shows a potential flaw in the system. I'm very happy with this. In fact, the police force did very well at repelling the.
All right. Let's check the audio. Didn't check the audio. All right. Oh, the audio seems to be just fine. Audio is fine. All right. Check it. All right. Let's see. 1 second. I keep getting messages. Fine. Let's see. Notifications. Start investing into actual textbooks. You are wasting your time watching badly intuited quantum nonsense. The absolutely best source are Feynman lectures. They are read by basically. Interesting. Okay, let's wait. This is a 7-minute video. So they read basically all physics professors living today. So they're saying that me watching a video like this is no good. I don't know why you would say that. I mean, and I don't know the name here. Larry Anton. Oh, it's Larry. It's a guy. So he says, actual textbooks. Yeah, I don't want to right now read a textbook. I'd rather watch YouTube videos. All right. So I'm just thinking what to watch. Okay, this is not important. We're up to 186 subscribers. That's pretty good. That's very, very good. Wait, I didn't want to do that. Subscribers. That's pretty good. Let's see. So, this is the next lecture. Quantum Mechanics Concepts 2 Photon Polarization Continued.
Continuing with the theme of photon polarization. Hello, today we are continuing in our series on quantum mechanics concepts, continuing with the theme of photon polarization. And if you'll recall,
Right, so yesterday we were studying quantum polarization or photon polarization. We were looking into this notation, right? This is the Hermitian operator or something. And this is the state of the system, and this is the result. Also the eigenvalue. This is the eigenvector, and it's the same vector. So given this, you run this observation, observable, measurable, and then this tells you whether it's a red light or a green light. Okay, but I don't know how useful this is. I mean, this is like when you don't understand the reason for an experiment, you don't have a theory, so at least you want to write down and be able to make predictions. But do you really understand? I mean, it doesn't sound like you're doing this from understanding, but let's see.
in the last video, we established a very important equation, which said that if we look at the top line, that tells us what the math says, that a Hermitian operator acting on a kept vector, which is called an eigenvector, will produce the same eigenvector, but multiplied by a real number, which is called an eigenvalue. And the point is that for every operator, there will be at least two, in our case there were only two, but there will be at least two eigenvectors, which will have associated eigenvalues. The point is the eigenvectors are different, and there is an associated different eigenvalue for each eigenvector. That's the mathematics. Now, underneath, we put down what that means in terms of the physics, that the Hermitian operator, or the Hermitian matrix, is the observable or the measurable. It's the experiment that you actually do to find something out. The eigenvector represents one of the many states of the system, and each eigenvector represents one of those states. And as I've said, there are two or more, and they are what's called orthogonal. What we mean by orthogonal is that if you are definitely in one of those states, then you are definitely not in any other. And then the eigenvalue is the result of the experiment. We set up an experiment which generated a red or a green light, depending on whether the photon was vertically or horizontally polarized. And so the red and the green light, which tell you whether...
This guy is so methodical and so mechanical and so straightforward and never skips steps. It's just watching his videos is like, you can't go wrong.
Whether it's vertical or horizontal, that's essentially the result of the experiment. You can't directly measure the Hermitian operator. You cannot directly measure the eigenvector. But the eigenvalue, which is the measurable, that is the result that you get, tells you what the eigenvector was, and therefore tells you what the state of the system was. Now, I just said that eigenvectors were orthogonal. By that, I mean that if you do the inner product of any two, AI and AK, these are both...
You get zero. The definition of orthogonal is the product must be zero. That's usually the definition of orthogonal.
Eigenvectors of the same Hermitian operator, then that will come out to 1 if I equals k, and it will come out to 0 if I does not equal k.
Well, if I equals k, it's the same one. If it's not, then it must be 0. Good.
And I can prove that for you or demonstrate it to be the case. Let's take a Hermitian operator acting on one of the eigenvectors, which we will just call A, to produce lambda, and I'll give this subset A to show that that is the eigenvalue associated with that eigenvector multiplied by the same eigenvector. And let's assume that the same Hermitian operator acts on another eigenvector, which this one we'll call B, to produce lambda B times B, or acting on B, I should say. So this is the same operator, but these A and B are two eigenvectors of that Hermitian operator. Now I can create something which looks like this. I can take this equation here, and I can write this. Now what does this mean? This just means that you take H and you operate on A, and that will give you a new kept vector. And then you take that new kept vector, and you do the inner product with B. That's all that means. Well, what is that? That's simply B, that's this here.
That's very interesting. So H, let's see what he says.
Times HA, and HA is lambda A times A. But when you've got a number, that number can come outside the inner product because it's just a number. And that gives you lambda A times the inner product of B with A. Now let's do it the other way around. We're going to take this equation here and we're going to do the inner product of
1 second, let me plug in.
this with A. So now we get that A, HB, so we've done the inner product here with A, is equal to A. Well, what is HB? HB is lambda B times B. But we can always take lambda B on the outside because it's just a number. So that equals lambda B with the inner product of A with B. And remember, the order always matters in this case. Now I'm going to take this result here, and I'm going to complex conjugate both sides. Now let's just remind you that if you take AB and you complex conjugate it, you get BA. We discovered that in the first video. So that's just to remind you of a something that we've already learned. So if we take this term here and complex conjugate it, essentially it just means reversing the two eigenvectors. So that becomes BH.
I have to go take gum because I'm already falling asleep. This is so boring. Oh my god. My brain is falling asleep. Give me a minute. I'll be right back. You know what? I'll play it and then I'll be back. 558.
A. And that's going to be equal to lambda B. And that's a real number, so you don't have to complex conjugate that. BA. In other words, you reverse these two. And if you're wondering why I didn't complex conjugate H, which I should have done, the answer, of course, is it's a Hermitian operator. And where you've got a Hermitian operator, it equals its own complex conjugate. So I didn't need to do that. So this is just this equation here, all complex conjugated. And now you'll notice that I've got two equations with BH. Let's get this right. With BHA. BHA equals lambda A, BA. And here we've got BHA equals lambda B, BA. So if I subtract the two, can we get them both on the screen? Yes. If I take that one minus that one, and that minus that, so I'm effectively subtracting one from the other. Obviously, on this side, BHA minus BHA is going to equal 0. And on this side, I'm going to have lambda A into the inner product of B and A. So lambda A into the inner product of B and A minus lambda B into the inner product of B and A. So lambda A minus lambda B into the inner product of B A. Now, in order for that product to be equal to 0, either that term or that term has to be equal to 0. Well, we've already established that lambda A and lambda B are separate and different because they are different eigenvalues associated with different eigenvectors. So lambda A and lambda B are different. They cannot be the same. So when you subtract one from the other, you don't get 0. Consequently, it is that term there that must be 0. And if you've got the inner product of two eigenvectors that comes to 0, we showed that that meant that they were orthogonal. And then we also learned in the last video of a term which looks like this. What that means is it's the inner product of x with y. And for physics purposes, it means that it is a probability amplitude. If you prepare a photon with the polarization of y.
I'll go back to 558.
Something that we've already learned. So if we take this term here and complex conjugate it, essentially it just means reversing the two eigenvectors. So that becomes BHA. And that's going to be equal to lambda B. And that's a real number, so you don't have to complex conjugate that. BA. In other words, you reverse these two. And if you're wondering why I didn't complex conjugate H, which I should have done, the answer, of course, is it's a Hermitian operator. And where you've got a Hermitian operator, it equals its own complex conjugate. So I didn't need to do that. So this is just this equation here, all complex conjugated. And now you'll notice that I've got two equations with BH. Let's get this right. With BHA. BHA equals lambda A, BA. And here we've got BHA equals lambda B, BA. So if I subtract the two, can we get them both on the screen? Yes. If I take that one minus that one, and that minus that, so I'm effectively subtracting one from the other. Obviously, on this side, BHA minus BHA is going to equal 0. And on this side, I'm going to have lambda A into the inner product of B and A. So lambda A into the inner product of B and A minus lambda B into the inner product of B and A. So lambda A minus lambda B into the inner product of B A. Now, in order for that product to be equal to 0, either that term or that term has to be equal to 0. Well, we've already established that lambda A and lambda B are separate and different because they are different eigenvalues associated with different eigenvectors. So lambda A and lambda B are different. They cannot be the same. So when you subtract one from the other, you don't get 0. Consequently, it is that term there that must be 0. And if you've got the inner product of two eigenvectors that comes to 0, we showed that that meant that they were orthogonal. And then we also learned in the last video of a term which looks like this. What that means is it's the inner product of x with y. And for physics purposes, it means that it is a probability amplitude. If you prepare a photon with a polarization of y, what is the probability amplitude that it will go through x? And that is given by this inner product of x with y. That's the probability amplitude. If you want the probability, you have to take the square, or more accurately, you have to take xy and the conjugate, complex conjugate of xy. But we write that as the modulus of the probability amplitude squared. And I explained that you cannot prove that that is the case. It is asserted that that is the probability amplitude and that the square is the probability, and it works. It always works, so we stick with it. And then we looked at 4 states of polarization of photons. And I've just written them out to save me writing them out again. We looked at the state of a polarization that was entirely horizontal. We represented that by the eigenvector 1, 0. I didn't tell you why, but I will explain in a moment. You could write that as being 1 times the x, where x is the horizontal component, plus 0 times y, because if it's horizontal, it's not vertical, and y is the vertical component. And if you were to plot that on an xy diagram, this is the x-axis, this is the y-axis, then this would be entirely along the x-axis, and its length would be represented by the length of here, that's 1, and it's entirely on the x-axis. And you'll recall that that eigenvector had an eigenvalue of +1. Then we looked at the vertical polarization, which we characterized as having the eigenvector 0, 1. And that could be written as 0 along the x-axis, because there is no horizontal component, plus 1 along the vertical axis. And when you plot that on an xy plane, it's entirely along the y-axis. it has a length 1 because that's 1 there, and we found that lambda, the eigenvalue, was -1 in this case. Now let's have a look at the /45 degrees / state, which we represented by an eigenvector of 1 over root 2, 1 over root 2, which you can also put as 1 over root 2 times the x direction plus 1 over root 2 times the y direction. And that means that you've got a 1 over root 2 in the x and a 1 over root 2 in the y, and that will give you a resultant vector at 45 degrees. And by Pythagoras, the length of that vector will be 1 over root 2 squared plus 1 over root 2 squared. That's a half plus a half is 1. You take the square root of 1, and that's 1. So again, you've got a vector of length 1 at 45 degrees to the horizontal in the / direction. And then we did a fourth one, which was the /45 degrees, which we represented by the eigenvector 1 over root 2 minus 1 over root 2, which you can write as 1 over root 2 of x minus 1 over root 2 of y. So if you plot that on the xy plane, you've still got 1 over root 2 in the x direction, but now minus 1 over root 2 in the y direction, which gives you a vector in the / direction. And its length will also be 1 because it's 1 over root 2 squared plus minus 1 over root 2 all squared is a half plus a half is 1. Take the square root and you've got 1. And for these two eigenvectors, we got, again, eigenvalues of 1 and -1. And I hope we can now see what these actual numbers, that I didn't tell you what they were, I simply asserted these two and then we derived these two. You can now, I hope, begin to see what they actually represent. These numbers represent the probability amplitude of the photon being able to go through a polarizer in the x or the y direction, in the horizontal or the vertical direction. Let's just have a look. Remember, probability amplitudes have to be squared. Strictly, you have to take them with their complex conjugate, but squared if there is no complex number in order to get to the probability. So what we're saying is that if the vector is 1, 0, and 1 is x and 0 is y, which is what we've got here, then the probability amplitude of going through the x is 1, which means the probability is 1 squared, which is 1, which means the probability of a photon that is in the horizontal polarized state going through a horizontal polarizer is 100%. And the probability of it going through a vertical polarizer will be 0 squared equals 0, no chance. Here, the probability of a photon polarized in the vertical direction going through a horizontal polarizer is 0 squared, 0, and going through a vertical polarizer is 1 squared, 100%. Then we take a photon polarized in the / direction. The probability of it going through a horizontal polarizer is 1 over root 2 squared, which is a half, and the probability of it going through a vertical polarizer is 1 over root 2 squared, a half. Exactly right. And then we take finally the /. What is the probability of it going through a horizontal polarizer? 1 over root 2 squared, a half. What is the probability of it going through a vertical polarizer? That's minus 1 over root 2 all squared, which again is a half. So these values in this vector here simply represent the probability amplitudes of a photon prepared in this state going through either the x, i.e. horizontal, or y, i.e. vertical polarizer. So now I want to use these 4 terms to see if we can guess what.
Wait, why is it -1/2? Well, it doesn't have any meaning. It's just a probability amplitude. Okay.
The vector will be, the eigenvector will be for a general polarizer, which is at an angle theta to the x-axis. So we're now just not going to just restrict ourselves to horizontal, vertical, or // We now want the general solution for any angle theta. I think you can see that what we're going to end up with on the graph over here is a vector which is going to be at an angle theta to the horizontal, and it's going to be of length 1, and it's going to be made up of some probability amplitude times the x basis plus a probability amplitude times the y basis. So let's just repeat that on the xy plane, where this is x and this is y. If we've got a vector which is at an angle theta to the horizontal, that angle is theta, and it's of length 1, then the vector, which we shall represent as this, that's the eigenvector, and it's an angle theta to the horizontal, is going to be characterized by 2 probability amplitudes, and alpha and beta. And that can be written as alpha times the x basis plus beta times the y basis. That was the pattern that we used throughout in the previous eigenvectors. So what is alpha and beta? Well, alpha will be the x coordinate, and beta will be the y coordinate. If the length of the vector is 1, it's pretty easy to see that the x coordinate is just the cosine of theta. So alpha is the cosine of theta. And beta, which is essentially the y coordinate, is the sine of theta, because the length is 1, so it's just sine theta. So if I'm right, that means that you can represent the, as it were, theta eigenvector by the general term cosine theta, sine theta. And let's just remind ourselves that these, therefore, we've now discovered our probability amplitudes, which you square to get probabilities. So if this is right, we could ask ourselves the question, if you prepare a photon in the theta direction, polarized in the theta direction, what is the probability of it going through an x or horizontal polarizer? Answer, cos squared theta. What is the probability of it going through a vertical polarizer? Answer, sine squared theta. And this sounds as though it might be right, because you may recall when we did the classical mechanics videos on electromagnetic radiation and looked at polarization then, we showed that if you put a photon first through a horizontal polarizer so that it's horizontally polarized, the intensity of the radiation that passes through a second polarizer that's at an angle theta will fall by cos squared theta. Now, in that video, what we were arguing was that the overall intensity of the radiation drops off by cosine squared theta. What we're now saying is, which of course amounts to the same thing, that the probability of any given photon prepared in the theta state going through a polarizer that is horizontally that is in the horizontal polarization direction is going to be cosine squared theta. So that amounts to the same thing. If the intensity falls off classically by cosine squared theta, that is exactly analogous to the fact that the probability of photons going through is cosine squared theta. So fewer will go through. And if fewer photons go through, then there will, of course, be less intensity, because each photon carries a certain amount of energy. The energy, of course, is represented by E equals hf, where h is Planck's constant, E is the energy, f is the frequency. So every little photon contains a quantum of energy, which contributes to the intensity. And if only cosine squared theta of them get through, then the intensity will fall off by cosine squared theta. So this result here completely agrees with what we get from the classical experiments. But of course, we'll need to do some tests to make sure that this works out. The first thing we need to do is if we take our polarizer at an angle theta, what we want to do is to find one that is orthogonal to it, that is 90 degrees to it. So there's the one this angle here is 90 degrees. And if that is 90 degrees, it's not difficult to show that that angle is also theta. So what now are the x and y coordinates of the, as it were, the reverse vector? Well, the x coordinate is going to be minus sine theta. And the y coordinate now is going to be cosine theta. So now I've got that as being my eigenvector for the orthogonal vector to the one which was at theta to the horizontal. That's that one, which just a moment ago we showed was cosine theta, or theta, and sine theta. So I assert that those two are orthogonal eigenvectors. And of course, if they are orthogonal, then we know that their inner product must be 0. So we better just check that. Is it true that these two vectors, that is, we prepare the photon in this state, which is orthogonal to this, and we ask ourselves, will it go through the polarizer, which is at an angle theta, to the horizontal? And the answer we are expecting is no, and therefore that this inner product will be 0. Well, is it? Let's just see. We take this term here, which is cosine theta, sine theta. So we write that, if you recall, as a row vector, and you take the inner product with the orthogonal eigenvector, which is minus sine theta, cosine theta. And of course, the rule we remember is you multiply that by that, and you add that times that. Well, cosine theta minus sine theta is one complete, that comes a minus cosine theta, sine theta. Add sine theta, cosine theta. So it's a minus plus, and that's going to equal 0. So yes, it turns out to be exactly what we would have expected. We better just check, of course. Let's do a few more of our tests. The next one we're going to do is we prepare it in the theta direction, and we ask, will it go through a polarizer at angle theta? Well, the answer is yes, it will, 100% certain. So the inner product of these two had better be 1. Is it?
1.
Well, let's just write it down. We've got the cosine theta, sine theta, which of course, just to remind you, should be complex conjugated, but there is no complex term, so we don't need to worry. There's no imaginary term. And then we multiply.
What does that say?
It's certain. So the inner product of these two had better be 1. Is it? Well, let's just write it down. We've got the cosine theta, sine theta, which of course just reminds
That says cosine theta. It's difficult to believe.
you should be complex conjugated, but there is no complex term, so we don't need to worry. There's no imaginary term. And then we multiply that by cosine theta, sine theta, and we get cosine theta times cosine theta is cosine theta squared plus sine theta times sine theta squared, cos squared plus sine squared equals 1. That works. Oh, and let's just be pedantic and check that the orthogonal versions of these, that's the orthogonal to the theta direction, if we prepare it in that state and try and put it through a polarizer in the same direction, of
1.
course it should go through 100%. Let's just test. That will be minus sine theta, minus sine theta, cosine theta. And once again, you've got minus times a minus will give you a plus sine squared theta, plus cos times cos, cos squared, sine squared plus cos squared equals 1. So far, it all works. Let's now do this inner product. That means we prepare it at an angle theta, and we ask, will it go through an X polarizer, in other words, a horizontal polarizer? Now, we've already answered that, because that, we said, is exactly what these terms tell you. These are the probability amplitudes of going through the X and the Y polarizers. So if the probability amplitudes are given here, the probabilities are the squares. So what is the probability of a photon polarized in the theta direction going through an X or horizontal polarizer? It's given by the square of this amplitude, cos squared. So we already know that. We worked it out. But this better be the same. If we prepare it in the theta and
Oh my god, I just fell asleep. Oh my god.
He was the blueprint.
Make your own.
His was perfect.
But insufficient. I understand. A lot of us old people are where you were when we were your age, and we know the disappointment firsthand. Yes, I'm not trying to dismiss what you. I felt this myself. So
Are you people talking about Trump?
but partially.
No,
but more
I'm
of a
talking
disappointment
about
in the system.
I'm talking about Tom Goldstein,
Who's that?
my idol,
Who is that?
my idol lawyer, whom I worshipped, stepped away. He still runs SCOTUS blog, which is like the best website
Oh,
ever.
that guy? I know SCOTUS blog.
Yes,
Okay.
the publisher, Tom Goldstein. He's gone. He's gone.
He's gone? Is that
He still does stuff on SCOTUS blog, but he left.
so? You like him?
Yes, he's my hero. I was gonna model everything I do as a lawyer after him. He was my sole source of hope. He was like, this is the guy who didn't do great in law school, who didn't have any connections, did not go to an Ivy League, but he made it and he became the best.
How?
The best. And I'm like, I could do it
How
because
did
he
he
did
do
it.
it? How did he do it? What's his secret?
Oh, well, it's not secrets because he told everyone what he did and everyone's going to be just like him,
So,
or at least
what-
I was.
so what's his method?
His cold calling. One of the things he would do is he would cold call potential clients,
hmm
right? That is something that nobody ever did before him, and I'm gonna do that. And in fact, I got my master's in public policy just so I would be able to figure out how to use statistics to find these people that I would cold call. Another thing he did is he went to Ivy Leagues and he opened up workshops there. Fucking genius move. That's how you network. I wanted to do that. Another thing that he would do is that he would just do everything. He was the best at writing briefs. I have his book. He was the best. He brought things. You know what else he would do? He would search for circuit breaks. Basically, when the highest courts in the state Supreme Courts, different circuits, they would disagree with each other on a case, he would suss those out, and then he would go call up the lawyers in those cases and be like, "Hey, I'm going to work for you for free. Just let me be part of this case," with the hope that it would end up before the Supreme Court. And when some of those lawyers would give up and say, "We're not doing it anymore," he'd be like, "Yo, I'm going to do it. I'm going to do it in your place." And he would do it. Fucking genius moves right there. So I'm going to do that too.
He became rich?
No. Yes? Maybe? That wasn't the point for me.
Then how do you judge if you want to model someone like why would you want to model someone who's poor?
Because the point is that only certain types of people get to bring cases to Supreme Court. Supreme Court is very biased and bastardly and asshole-ish when it comes to what cases they will take. A lot of it comes down to who is the lawyer? Is that guy good enough? Probably not. We're not going to take him then, because there are 8 lawyers who take the 25% of the cases to the Supreme Court. Just 8 people. Let that sink in. What an injustice that is. And who are those people? 7 of them are people that I could never be. I don't have the pedigree. I don't have the gender. Then again, I don't have Goldstein's gender, but that's not the point. I don't got the money. I don't have the rep, but Goldstein's different. He's just like me.
Well, he's still got his firm. He's still practicing as part of Goldstein and Russell, isn't he?
No, he don't. He left. He's only got one case that he's doing now, and after that, he's done completely. But he left his firm.
So what's he going to do now?
He's going to be doing computer stuff because he's actually a genius at that. And part of his huge success was his website, SCOTUS blog, and part of why it's so amazing is because he developed programs that people could use to learn to make predictions about what kinds of cases will move forward, not the result, but what kinds will move forward. And he was a brilliant analyst of what's going on in Supreme Court justices' heads. And he said, I'm going to make an awesome computer program because he has a computer's background. And so, another reason why he's so amazing is because he's multi-talented. And that's why I went and I got 2 master's degrees just so I could be like him, but in different topics, right? So he's, but he's gone. He's not doing law
but surely
anymore.
if he's an inspiration to you, surely he's inspiration because of what he's done. So you still got that to look back on.
He says
and so
what
that's
he's
you to
done.
Inspire you.
He says what he's done.
This path.
I mean, you can't have. I'm holding my cell phone right now. Now I have an option. I can either break my cell phone or not break my cell phone. If I'm predetermined to break my cell phone, that means if I decide, I can't even decide to not break it. I would have to break it. You can't have free will and everything's already determined at the same time.
Eventually, your phone's going to break by itself. With
I know, but I could break it right now, though.
You could,
or I could not break it right now. If it's predetermined, I'm going to do one thing or the other, and I don't even have a say in it. Or I
And
have
what
free
is
will, and I
predetermined is that your
decide to
phone
do-
is going to not work one day.
That's irrelevant. Completely
No, it's
irrelevant
not.
that my phone's not going to work one
The
day.
well, the end game is that the phone is not going to work one day, and you're just describing in which method that's going to happen. Whether you do it intentionally, whether you do it over time, or it does it by itself.
Total non sequitur to the
It is not.
conversation we're having.
That was almost good, but not
entropical.
quite. Yeah.
I've got an
No,
example.
the components inside them are going to degrade. The batteries are going to off gas, and all the circuits are going to break down. And then
Don't try to
over
butter
time,
up to
plastics
SE
are
by
gonna
mentioning off gassing.
fall
All right,
apart.
this is the relevant to the point we're making. We're talking about if I'm going to break it right now or not break it right now.
Yeah.
Well, then
Doesn't
you're
matter if
setting your
it's
own
gonna break in
parameters.
50
I'm
years.
saying God's setting the parameters. There's going to be a terminal outcome at some point, set by
It's
God, not by you.
irrelevant. We're talking about if I decide to break my phone now or don't break it now.
Okay.
Like, I guess if you go down to the definition of like free will, obviously will being your own will, which it's like you're limited to essentially the decisions of your conscious choices. And
Pick a roulette table, right? Pick a roulette table. You spin it, right? You either know where the ball's gonna land, or you don't. It's as simple as that.
Mm-hmm.
Well, I think
For
that
me, anyway.
compatibilism is like more of the idea. Like, for an example of it would be like, you're a student, you have a test or an assignment, and there's a deadline, but you can do the assignment and then choose whether or not to submit the assignment.
I mean, on the predestination and free will, like how they would both be compatible is that like predestination specifically when it comes to like being saved, like having the Holy Spirit essentially like be within you. That is not a choice that you can make. That is something that like in no capacity do you have the choice to just have the Holy Spirit inside of you. So that is a choice that like God makes that you have no control over. So that would be in a sense predestined. But then there's free will in other capacities, obviously.
Well, can I ask you a question, Yasuke?
What's up?
Does your God that you believe in see the future?
Himself to another to a legal team rather than being the legal lead, correct?
No, not quite.
And put it through an X or horizontal polarizer, we should get a probability of a half. Let's see if we do. So we are going to take the in the theta and put it through an X or horizontal polarizer, we should get a probability of a half. Let's see. See if he said is exactly theta plus sine theta, cosine theta, minus sine theta, cosine theta. And once again, you've got minus times a minus will give you a plus sine squared theta, plus cos times cos, cos squared, sine squared plus cos squared equals 1. So far, it all works. Let's now do this inner product. That means we prepare it at an angle theta, and we ask, will it go through an X polarizer, in other words, a horizontal polarizer. Now, we've already answered that, because that we said is exactly what these terms tell you. These are the probability amplitudes of going through the X and the Y polarizers. So if the probability amplitudes are given here, the probabilities are the squares. So what is the probability of a photon polarized in the theta direction going through an X or horizontal polarizer? It's given by the square of this amplitude, cos squared. So we already know that, we worked it out. But this better be the same. If we prepare it in the theta and put it through an X or horizontal polarizer, we should get a probability of a half. Let's see if we do. So we are going to take the So I assert that those two are orthogonal eigenvectors. And of course, if they are orthogonal, then we know that their inner product must be 0. So we better just check that. Is it true that these two vectors, that is, we prepare the photon in this state, which is orthogonal to this, and we ask ourselves, will it go through the polarizer, which is at an angle theta, to the horizontal? And the answer we are expecting is no, and therefore that this inner product will be 0. Well, is it? Let's just see. We take this term here, which is cosine theta, sine theta. So we write that, if you recall, as a row vector, and you take the inner product with the orthogonal eigenvector, which is minus sine theta, cosine theta. And of course, the rule, remember, is you multiply that by that, and you add that times that. Well, cosine theta minus sine theta is one complete, that comes a minus cosine theta sine theta. Add sine theta cosine theta. So it's a minus plus, and that's going to equal 0. So yes, it turns out to be exactly what we would have expected. We better just check, of course.
The winds blow, but certainly other countries. No radical, fundamental principles of freedom, rational self-interest, and individual rights. This is the Iran. I'm going to do a little bit on Nasrallah, and then we'll take our usual AMA Ask Me Anything show. And so far, we've got 2 panelists on with us today, so there's plenty of time to answer your super chat questions. So please get them ready and line. Is administration and the Obama administration handed Iraq special edition of the Iran Book Show. All right, everybody, welcome to the Iran Book Show on this Sunday, September 29th.
Oh, my mute was on.
Show, kind of giving you a update on my views about the war in the Middle East, what's going on with Hezbollah, but really in a much broader sense, what's going on with the broader war in the Middle East. And so thank you for joining, and of course you can help shape the conversation today by asking questions on the super chat, please, in the Middle East. Then we're going to summarize by asking, are we heading toward the new Middle East? Jared Kushner has over the last 2 days, and then we'll talk about a little bit of going on the conversation today by asking questions on the super chat. Please do that. But what are we going to cover today? We're going to talk. I'm going to give you a quick update on what's going on right now. That is today, what has happened over the last 2 days, and then we'll talk about a little bit of the history of Hezbollah and the conflict with Iran. We're going to talk about, is this a regional war? Is it already a regional war? And put it into the context of what's going on in Gaza and everything else kind of in the Middle East. Then we're going to summarize by asking, are we heading towards the new Middle East? Jared Kushner has a short, it's not an essay, but a short statement on Twitter about this is the beginning of a new Middle East. We'll talk about, is this a new Middle East? Is something dramatically new happening here? And then we'll see what we get from there. As part of this, hopefully we'll have an opportunity to talk about kind of the West response to Nasrallah's death and the whole de-escalation BS that the Biden administration, as well as many people in the West, Macron and others, are pushing for. So that's the program. We might as well just jump right in with a few of kind of the highlights of the news today. Again, just from the conflict, just in the Middle East. We'll do a full news show covering some of the news I missed during the week tomorrow. Tomorrow's show will be at 7 p.m. So 7 p.m. tomorrow we will have a show on an update, a kind of a news catch-up show. So that'll be 7 p.m. tomorrow, Monday. All right, quickly. So let's do this. So Nasrallah's body has been found in the bunker where he died. The good news is for the Shiites is that the body has been found intact. The good news from my perspective is Nasrallah did not die from the collapse of the bunker on top of him. That would have been too fast and quick of a death for a monster like Nasrallah. Nasrallah died slowly. He died from the gases emitted into the room from the explosion. He was in some crevice in the bunker that did not collapse on him. So he died a nice, slow, agonizing death where he got to think about, I guess, the virgins waiting for him in heaven, or fear that maybe God would actually put him in hell, or maybe there is no God, or just the fact that those Israelis got him. They got him. And even though he didn't have a beeper and no walkie-talkies or anything else, he got to die slowly. So, so that's, the body's been discovered. There will be a funeral tomorrow in Beirut. This will be massive. Although I have a feeling that the leadership, whatever's left of Hezbollah leadership, not much, not many people are left. Hezbollah leadership might be absent from the event, fear of maybe a sniper attack or who knows what. It's also, so the funeral will be held tomorrow. There's also an expectation that Hezbollah would announce tomorrow who the heir to Nasrallah is. There seems to be some conflict within the organization in terms of who that should be and what direction the organization should take, and what, for example, whether they should attempt to continue the current war with Israel right now. The leading candidate for the replacement of Nasrallah is, I think, his nephew, Saif ad-Din, who is also
He's already dead. They already killed him.
married to the daughter of Soleimani. Remember Soleimani, the guy that the Iranians that Trump had assassinated? He has good relations with the Iranians, and he spent a lot of time in Iran. He studied in Homs. Homs is the kind of spiritual home of Shiite Islam, and where all the Iranian clerics, all the Shiite clerics get trained. It is likely that this guy will be the next leader of Hezbollah. He has been with the organization over 30 years. He's in his I think he's in his 60s. No, he's in his 50s. I think he's in his 50s. He's been kind of, I was going to say Bin Laden because they're all the same monsters. But he's been Nasrallah's right-hand man for decades now. He knows him, again, family relations, and he's been part of this for a very long time. He's also, funnily enough or not, he looks a lot like Nasrallah. He sounds a lot like Nasrallah, although he doesn't have that, whatever it is that Nasrallah had, that kind of, which they claim is some kind of, a certain charisma. He doesn't have that, and he's not a great orator like they claim Nasrallah was. So that is probably going to be the new head. Israel, over the last 48 hours, or really since the bombing of Nasrallah's bunker and the killing of Nasrallah, they haven't stopped, amazingly. They have been bombing ruthlessly throughout South Lebanon, the Bekaa Valley, North Lebanon, and in that neighborhood in Beirut, the neighborhood where the Shiites dominate. By the way, I looked at a graph. I saw this little graph that showed that this neighborhood, where basically Hezbollah runs everything, this neighborhood in 1975 was a 50% Christian neighborhood. There were basically no Shiites there. Sunnis, Christians, primarily Christians of various denominations. No Shiites there, and now it's 100% Shia, dominated by Hezbollah. Anyway, they've been attacking there. They killed a number of additional people in the leadership of Hezbollah. So they're making the decision about who should replace Nasrallah fairly easy because they're basically killing all the candidates, except maybe the one who's left over. Let's see. So Israel continues to attack all over Lebanon and destroying infrastructure, destroying caches of weapon systems, destroying the capability to launch weapons because they're destroying launches. Nasrallah died, and the response has been pretty muted. I mean, nobody could have believed that this would indeed be the case. But everybody expected if Nasrallah was ever taking out thousands, tens of thousands of rockets would be launched against Israel. Barrage there, many of them falling in completely uninhabited areas. As if they've lost the capability of targeting them. That could be because the people actually know what they were doing, all being killed. It could be that Israel's destroyed their smarter bombs. Anyway, just nothing. No Israeli has died since Nasrallah's death. I don't think maybe somebody's been injured, but no Israeli's died since Nasrallah's death, which is pretty amazing. Pretty amazing. Completely unexpected. Nobody saw this coming. I mean, Hezbollah was this mighty force that Israel was doomed to even try to deal with. And it's just fizzled away. Israel continues to attack Lebanon, Syria, Hezbollah targets. There's rumors, about 12 hours ago, there were rumors of the beginning of an Israeli ground invasion into southern Lebanon, or incursion into southern Lebanon. I don't know that that's happened. It's gone silent, so this is not something that could go. If they're invading, everybody in the world would know. So I have a sense that this is that was maybe a special op or something like that, but not a full-scale entry into South Lebanon. Whether that's justified, whether that's needed or not, we can talk about it in a little while. But certainly that does not seem to have happened yet. Does not seem to happen. Over the last 48 hours, the Houthis have launched. Actually, even before that, while I was in Israel, just before I arrived in Israel, the Houthis launched in southwards Tel Aviv. They've launched a few others since then. So Israel responded today, 1,800 kilometers away from Israel. They responded with airplanes flying there, with fighter planes and bombers, and refueling airplanes. So a massive operation, 1,800 kilometers away from Israel's base. So that's over 1,000 miles. Israel basically destroyed another of the kind of oil facilities in the port that the Houthis control, and they destroyed a couple of power stations in Yemen. I don't know how much this is going to slow down the Houthis.
I think Israel has to get an aircraft carrier. They have to have it.
A lot more
Israel needs to have its own fleet.
Needs to be done in order to destroy their capabilities. It's hard to believe that Israel could do it alone. I mean, it probably could, but it would be very expensive and very time-consuming and very effort-consuming. Whereas the United States could do it in hours and crush the Houthis and destroy them. This operation against the Houthis that Israel engaged in was coordinated with the U.S. The U.S. was aware of it. They'd give it a thumbs up. Why it didn't participate, given that it's U.S. trade, it's U.S. fleet that's bogged down over there, it's U.S. trade that is being destroyed, it's European trade. Why NATO isn't down there eviscerating the Houthis? Only God knows. No, I mean, this is exactly the sign. Israel here is leading the West away from its dedication to compromise and appeasement. And the West is resisting that. So Israel's showing the way, and the West is going, well, we're not quite ready. No, we want to peace some more. We want to de-escalate. We're afraid. No, we're not. We can't do it. So Israel's attacking the Houthis, which the West should have done months and months ago. And the U.S., which has gazillions of assets right near the Houthis right there, is just sitting back. And I guess, the Israelis let them know primarily because the U.S. is active in that region, flying around. They don't encounter dozens of Israeli planes suddenly coming at them unexpectedly. So they had to tell them. But it's just truly unbelievable. All right, as part of this, just mentality of weakness, mentality of appeasement, mentality of no self-esteem, no assertion, no, actually enforcing America's right to self-defense, which we'll talk about again some more. Biden and Harris both responded to the killing of Nasrallah. They both had, good things to say in the sense that Nasrallah has a lot of American blood in his hands, and this is an act of justice, and so on. But then both of them ended the commentary with something like, and now all we need is a ceasefire so this doesn't escalate. And you want to shoot them. You want to just rip your hair out with frustration that a political class still does not understand what's going on here and what's at play and what's involved and how what you need is escalation. What you need is victory. What you need is to finish a war started in 1979. What you need is to complete it. And what you need is to help Israel finish it rather than sitting on the sidelines. Yeah, that was good. It's an act of justice. They killed Nasrallah. Good. Thumbs up. Now, please, ceasefire. We got to stop because we might upset the Iranians. And who the F cares if you upset the Iranians? Who cares? Isn't no point upsetting the Iranians? Maybe to the point of being victorious over them. All right, anyway, Yair says the sirens over Haifa right now. It is, what is it? It's 7 p.m. in Haifa right now. So the sirens, so yeah, they're going to be sirens. They're going to launch attacks. They're going to launch their missiles. They haven't been effective so far. There's no reason to believe they are going to be, but I have a feeling Yair is going to keep us updated to the extent that they are. So Biden and Harris, well, at least not saying mourning and presenting the condolences for the killing of Nasrallah. At least they're saying good riddance is an act of justice. Good for them for saying that. Then they go on and there's compromise. In the meantime, Netanyahu, I mean, the guy is, you got to give it to him. The guy is a political genius. He's just a political genius. I don't know anybody in any country, anywhere, who has the survival skills of this guy. It's just, he sensed that it was time to go north because Gaza was mainly not quite done, but was a place where there wasn't much to do. His coalition was fragmenting. There was a lot of infighting about a bunch of different things, particularly the drafting of the ultra-Orthodox. And he needed to bolster his coalition. So, he also sensed that Israelis and his defense secretary were basically pushing for doing something with Hezbollah in the north and allowing Israeli citizens to go back to their homes in the north and bringing some normalcy to life. So he went to the north, and they did this progression, and amazing. What Israel did in the last 2 weeks will go down in history as one of the most brilliant campaigns ever. And from an intelligence perspective, from an execution perspective, it's just brilliant. Now remember, the foe has no aerial defenses, has nothing. I mean, you're basically in the air, free to do what you want. It also shows the power of air power when you can establish air power, just how much you can achieve, which is a whole other discussion. I mean, if Ukraine has started something about modern warfare, so is what's happened now in Lebanon has started something about modern warfare and the world of air power. And one of the challenges Ukraine has is, but you see that with Russia as well. Neither one of them has control over the air, which makes the war much more difficult. But so Netanyahu did what he did, and he got tough. And in the meantime, he started negotiating with this other political party that's kind of right of center, former members of the Likud, former members of his political party, who left because they didn't like him. They didn't like the way he ran things. They were upset at him years ago. They left. They formed their own party. They're in the Knesset. Gideon Saar and a number of other members. And they have been since October 7th scathing in the criticism of Netanyahu, in the criticism of the execution of the war, mainly from, if you will, I won't say from the right, but from a more assertive perspective. They were better. I actually interviewed one of the members of that political party on my show in Hebrew, where she basically stood Netanyahu. And I mean, she was more scathing about Netanyahu than I am. And she articulated what a victory would look like, and she was absolutely 100% right. And she talked about Netanyahu's big gun speeches and everything but action. Anyway, so Netanyahu basically took something out of their playbook and got really, really tough in Lebanon, right? And as a consequence, has now gotten this political party to join his coalition. It gives him now 4 new members to the coalition. And by giving him 4 new members to the coalition, he basically has taken away kind of the veto power the crazy religious party of Ben Gvir has over the coalition, which is good. But he's also given it life. And he basically has secured himself the prime minister's position in Israel until 2026, which after October 7th was literally unthinkable. The guy has maneuvered the entire political system in Israel and maneuvered the war itself in order to preserve himself in the position of prime minister until 2026, where he will probably, by then, who knows what will happen. But it's just politically stunning. I don't have any comparison. It's bigger than even Trump being able to come back after January 6th. It really is a stunning achievement politically. I mean, I consider it a vice, not a virtue, right? To be this kind of politician, scheming and manipulating and seeing the opportunities to preserve your power, and not taking responsibility and not taking responsibility for the bad stuff you have done. I'm also pretty low on Gideon Saar for joining this government, but so be it. And that is politics. That is Israeli politics. I'm really interested in interviewing the woman who's a member of the Knesset who was so scathing about Netanyahu, who's not part of the government. It would be interesting to interview her and see. I do not. I know everybody wants to give Netanyahu credit for this. I do not give Netanyahu credit for this. Netanyahu did this because he was pushed into a corner. And this is not about leadership. This is about stunning intelligence, unbelievably military execution. This is about the Israeli army redeeming itself for 10-7. This is about a military force that is probably the best in the world. It's small, but it's, in terms of execution, probably the best in the world. Unbelievable intelligence capabilities, the strategy and everything, which was years and years and years in the making, and a political leadership that has not known, and this is Netanyahu because he's been prime minister forever, has not known how to take advantage of these capabilities until they were put in a corner and they had no choice to do it. And again, Netanyahu was pushed into this by the defense secretary. He was pushed into this by his opposition. He was pushed into this by the Israeli public, and he was pushed into this by needing a distraction from the hostages. So. I'm never going to win this battle with you guys who love Bibi. I think in spite of the success here, I think he is an unmitigated disaster. I think most Israeli politicians would have executed what just happened, and many of them would have executed even earlier than what happened now. But I'm just not able to convince some people who are blinded by his amazing speeches that he gives. All right, 2 other things that are kind of happening, and then we'll kind of do a kind of a bigger picture historical analysis of what is going on. Here. One is. It is interesting in the West to observe who is mourning Nasrallah, right? So if you look at AP, this is you get a sense of kind of the so-called bias. This is like an anti-civilizational bias. AP's headline is charismatic and shrewd. A look at longtime Hezbollah leader Hassan Nasrallah. Charismatic, shrewd. Nothing there about him being a vicious homicidal terrorist who unbelievably destructive and just responsible for wars and the deaths of hundreds, thousands of people over the years, really tens of thousands if you include Syria. Here's the New York Times. Over his 32 years of leadership, leading the organization, and with the support of Iran, he built Hezbollah into a domestic political force and one of the most heavily armed non-state forces in the world. Mr. Nasrallah was opposed to Israel, which he called the Zionist entity, and maintained that there should be one Palestinian
Mr.
Palestine with
Nasrallah.
equality for Muslims, Jews, and Christians. A powerful orator, he was beloved among many Shiite Muslims, a historically marginalized group in Arab world, and created a state within a state in Lebanon that provided social services. I mean, this is insanity.
Social services.
Nasrallah in one interview said he believed in one state with equality of Muslims, Jews, and Christians. But in every other occasion, he was very clear about the fact that he supported a global jihad and the establishment of Sharia law over all of the world, never mind over Israel. He had no intentions of creating an equal one-state solution for Palestine, even though, again, he did mention it in one interview. There's a horrible interview of Nasrallah by the guy from WikiLeaks. What's his name? The guy was released recently from WikiLeaks. Again, just showing how, particularly the WikiLeaks guy, was so enamored with people like Assange, was so who many people call a hero, was so enamored with people like Nasrallah and just groveled and just sucked up to him in a horrible interview. So Julian Assange is part of this, supportive of this. This is the Washington Post. Among his followers, Mr. Nasrallah was seen as a father figure, a moral compass, and a political guide. He was lauded as a man who empowered Lebanon's own downtrodden and impoverished Shiite community and protected it from Israeli incursions by turning Hezbollah into a formidable deterrent force. So, I mean, you couldn't write better propaganda if you were Hezbollah. I mean, basically, Western media is presenting in perfect synchrony the party line, Hezbollah's party line here. Here's the Guardian. This is the headline.
Okay. What do we got? Hello.
Hello.
What's up?
Not a whole lot. What's up with you?
Does
What's on
anybody,
your mind this morning, as they say on talk shows?
the same as always. Does anybody want to talk about physics?
No. What's there to know about physics that we need to know?
Or do you know everything about physics? Have you
Oh
solved?
God, no.
So
Not even close.
Nobody
I took
does.
college physics. Yeah, I took a year of physics in college, and I know a bit about some things, but it's all rudimentary. It's all just the basics.
So
My question is, why do you care about physics?
that's a good question.
I thought so. That's why I asked it.
Right. So that's like the last piece of the puzzle for me. I solved everything else.
Oh, really?
Yeah.
Good for you. All right.
Yeah.
Nice.
Yeah. So but if
So
this
what do you still want to know about physics that you don't know yet?
I'm trying to put the puzzle together, the pieces of the puzzle together within physics. I'm like, I don't know how the Higgs boson gets created, for example.
Yeah, no one does, I don't think.
No, they predicted it.
Yeah, no.
So they predicted it exactly at 126 MeVs or something.
Yeah.
Or GeV.
Yeah, but it was the math, right? It was the math they did.
So how did they
Can
know?
you do the math?
No,
I can't do the math.
It's not even.
I'll tell you straight up, I cannot do that math.
No. Before you get to the math, I don't know the theory. Like, why should there be a boson? Like, I understand the Higgs field. I understand
Because it makes the math work.
How?
Well, you have to understand the math in order to understand why it makes the math work. And I don't understand the math, but I know that's why they do it.
In general, when you say understand the math is just a modeling tool. It's just a tool to model reality. It's just a tool to to understand.
Sure.
So it's not about the math. It's about the modeling. So what's the model? And the model is something you should be able to imagine. Like,
no, not true. No.
Oh,
there's mathematics we cannot instantiate in terms of a physical model or something in our minds. No.
No, but
imaginary numbers are one of those things, right? I can't imagine an imaginary number. What is I? Square root of -1. I can't imagine that thing.
Right, but when it comes to reality, there's no like I should be able to imagine reality. Like reality must be mechanical.
No, it mustn't. No, it doesn't have to be.
So you're saying that it's possible that we don't understand reality?
at that level of, the essential nature of the universe? Of course not. We're just humans.
Then
We're just primates. We're three steps out of the trees.
Then I would argue that you're an anti-scientist.
Well, you'd be wrong.
But what you're saying is,
well, first of all, okay, let's back up. What is science? What do you think science is?
It's exactly what I'm saying. Science is the assumption that the universe is mechanical. And
I don't think that has anything to do with science.
Well, my science. So according to me, science is the assumption that the universe is mechanical, is simple, is understandable. That's the assumption called science. All of this is
no.
Well,
yeah, I would disagree with you. I think science is human beings trying to understand how the world works.
Yes, but the assumption is it's understandable.
No, the assumption is parts of it at least are understandable, and those things we can understand through science.
So
there may be parts of it that aren't understandable.
Right.
And on those things, we're screwed. We just will never understand them because we can't.
So it could be, according to you, that there is a God and there are spirits and there is demons and Jesus rose and stuff like that. And it could
no.
That is
no.
Yes, that's
not according to me.
Yeah.
No, you said according to me. Not according to me. No.
You look, when you say the universe might not make sense, that's what you're saying. You're saying that maybe 1 + 1 is not 2. Maybe 1 + 1 is 7.
No, I said I said when we dig down far enough into it, we may get to a level that we cannot understand.
Right.
Because our brains are not the kinds of things that can understand that kind of thing.
Right. So I'm claiming that must lead you to reject logic.
No.
Yes. Because according to you, the universe might make no sense. So it might be that 1 + 1 = 2 is both true and not true, and there's no contradiction, and there is a contradiction, but it's not. Yes,
not at all.
That is
not
what.
At all.
Look,
no.
Yes, that's what you're saying. That is what you're saying.
Why don't instead of you tell me what I'm saying, ask what I'm saying?
You're saying.
Ask for clarification.
Go ahead, clarify. I mean, you're welcome to try and clarify. I mean,
did I say the entire universe makes no sense?
It doesn't matter.
Everything about the universe makes no sense. No, it does matter. It matters a lot.
Even if one tiny bit in the universe might make no sense, according to you, so that means that anything could be true. And it's not a contradiction, and contradictions.
That's just illogical.
It's
no,
what?
That does not follow. No, if there's a part of the universe we don't yet understand and may never understand, that does not mean everything else we do understand about it is going to change one bit.
What does it mean to not understand something? Right? I can't even imagine what it means to not understand something.
That is the problem of not understanding something, right?
No.
Okay, here's an example. Why is there something rather than nothing? And let's not go to whatever his name is who talks about, things breaking up in an energy field. Why is the energy field? Why is something? I think that's a question we will never know the answer to.
Yes, I agree with that.
Okay. That's an example of not understanding. And for my own monkey mind, the idea of whether there was a start to everything or whether it always existed, neither of those make any sense to my monkey mind. Both of those things are impossible.
But you're not contradicting me. See, so I'm saying, look, if you're saying something might make no sense.
I didn't say that. I said we don't understand it.
Right.
You're the one who said maybe sense.
Right. Fine. That if you say we might not understand this universe. This universe might be not understandable. That there's
No, I didn't say that. I said parts of the universe we will never understand.
yes. So,
but the vast majority of it, well, I'm assuming that the vast majority of it, but a lot of it we do understand perfectly well.
but I'm not even saying that we do or don't understand. I'm saying science is the assumption that the universe is completely understandable. And
no, it's not. It's an assumption that it's consistent. And it's not the assumption that we will understand all of the consistencies.
No. It could be consistently illogical, consistently violating logic. That's the universe cannot.
No. Nobody makes that assumption.
No, but when you say it must be consistent, then it could be consistently irrational, and according to you, that could be the universe. We could be.
Not according to me. You got to stop saying that.
No, but that is what comes out of your position. Your position must lead to the conclusion. I'm making you face the conclusion of your position.
Your conclusion is not correct, though.
Well,
there's nothing for me to face.
I think it is.
I know you do. That's why you said it. But I know it isn't.
No, it doesn't. Your knowing and me knowing is identical. So you don't have an upper hand about where your position leads. We can debate it.
Oh, I do.
No, you don't have any insight as more than I do about where your position leads. So
well, my position is not one where things can be consistently inconsistent. That's not my position.
I understand, but you say you know.
Well, it can't be my position.
No, but you keep saying that you know where your position leads, and I am wrong.
I do.
No, you don't. Me
about
and you.
About my position, yes.
No, about the conclusion of your position, where it leads. We are on equal footings. Me and you have.
Okay, if my position is that the universe is consistent, and the meaning of that is it cannot be consistently inconsistent because that's a paradox and an internal contradiction. So that can't be where my position leads, right?
Yes, it can. So, and we can enter a debate in which we are equals. You don't have the higher logical ground in this debate. So we can honestly debate where your position leads to.
So if my position is one that the universe is not consistently inconsistent, you think you can argue that I actually do believe that?
Well,
go for it. I'd like to hear this.
I mean, you just changed your position, so that's fine. So look, my claim is that
no, I elaborated my position.
It's fine. Let's start
because it obviously wasn't sufficient the first time I said it. You drew a conclusion which I assumed nobody would draw because I thought you'd understand the language I used.
I gave you an example.
So I clarified.
I gave you an example. So you claim that this universe might be not understandable completely, right? That's your position.
Oh yeah, not all of it might be understandable.
Sure,
a lot of it is.
Sure, but there might be something in this universe that is not understandable.
Correct.
Okay, for me, that just says that some part of this universe might be magical. That is what you're saying. No. Right. Okay.
Not at all.
Okay. To me, that is what you're saying. Now, right. Let's enter a debate and let me try and convince you that you believe in magic. You believe in a magical.
Good luck. Go ahead. Yeah, I'd like to hear this.
I mean, that is what I believe is your position. That is what I feel.
Go ahead.
I mean, so
Give it a shot.
Right. So I'm trying to imagine what it means, right, to not understand something. That means that something doesn't follow. Like you would say the cause and the effect don't follow. To me, that is magic. That is magical. I would say that's the definition of magic. What else is magic? Otherwise, it's mechanical, right? Right? You would say there is an aspect of this universe where causality, the mechanism of causality, breaks down. Something happens that we cannot explain, meaning we cannot trace cause to effect. So I would say that is literally the essence of magic. That's nothing but that is magic. What else is magic? What else is a religion, is God, is angels, all those things, and demons? So you believe in this fantastic universe. In this
Where did I say any of that though?
You're welcome to
paraphrase something I said that would suggest that I believe.
Well, I just went through a mechanical explanation of why that must be your position. I can go through it again and step by step.
Quantum physics is the law, the quantum physics and probability, right? Do you think there's something mechanical underlying that?
Absolutely, it's completely mechanical.
Really? Why?
What do you mean, why? I mean, for me, of course, it's...
Why do you think so?
Oh, for me, it's ether, so of course it's mechanical. I've already resolved most of it. When I listen to...
Really?
Sure. When I listen to...
How did you resolve that?
Well, ask me anything in quantum physics. I'll explain it.
I don't know anything about quantum physics. So tell me everything you know about quantum physics.
There's very little to know. It's just...
Educate me.
Sure. There's
very little to know. Okay.
Yes. Quantum physics is completely classical. It's completely mechanical. There's nothing different about quantum physics or quantum mechanics than classical Newtonian mechanics. It's just that quantum physics... Go ahead. What's the question?
You think the people who study quantum physics would agree with you?
I don't care. I honestly don't care.
Oh, okay. All right, that's good. Okay. Let's know where you're coming from.
Okay. So
you're smarter than them. Okay, go ahead.
I don't care. I'm not. Well, you see where you're going? That's not a proper debate.
But this is where what you said leads to. If you think if you don't care what the people who spent their lives studying quantum physics believe,
I don't know what they did.
Because you think you have an answer that they don't agree with, then you must be smarter than them.
I don't know what they did. I don't know what they did with their lives, and I don't care. I barely know what I'm... Yeah. What do you mean you know? Okay, so I don't care. So why do you bring it up?
Because you're assuming you know better than them.
I don't care about anyone except for you, me, and quantum mechanics. Why are you bringing up...
I don't know anything about quantum mechanics.
Excuse me?
I defer to the experts on fields that I don't know.
I don't.
And I know there are experts on quantum mechanics. I know there's people who spent their life studying this topic.
Okay, you asked me. I told you. Look, you asked me about. You brought up quantum mechanics.
Okay, what is quantum mechanics then? Tell me what it is.
Okay, so quantum mechanics is, I would say, identical to Newtonian mechanics, except for it's a lot of it is wave mechanics, but it's still wave mechanics is, we know how to analyze waves mechanically, and like what we call elementary particles are just waves in the ether. So for example, a photon is a wave. It's a wave. I call it a wave packet. Other people have called it a wave packet in such a way that it maintains its integrity and it fizzles out very slowly. But it has, when you look from the distance or when you use a particle detector, it looks like a particle. But that's because on close inspection, it's a wave packet. It's a wave that doesn't disperse so quickly.
What does upon close inspection mean?
On close inspection, like the young double slit experiment. It's clearly a wave. When like any analysis you do, I mean, Maxwell showed that electromagnetic radiation is a wave. I mean, everything we know about the photon says that it's a wave. Now, some people claim that there is a particle wave duality, and I've been able to completely get rid of the duality. So for me, it's
Really? How'd you do that?
I just assumed. I mean, because my ether doesn't allow for particles, so I was forced to get rid of particles. Once I got rid of particles, you have a question?
So you just waved your hand and made them go away. Interesting technique. Okay, keep going.
What do you? I didn't say I waved my hand. I told you exactly what happened.
Well, you said your ether didn't allow them, so you just ignored them.
That's not what I said. So.
Oh, wait, what'd you say? Sorry, Sorry, I don't mean to misquote you.
All right. So I came to the conclusion that the universe must be filled with an ether, with a fluid that is flowing through me right now at 11 kilometers a second. And I couldn't figure out
How'd you come to that conclusion?
Excuse me?
How'd you come to that conclusion?
That's from Newtonian mechanics. You can easily show from Newtonian mechanics that from just F equals ma and F equals GMM and F equals GMM over and F equals GMM over R squared. So,
and can we map this flow somewhere? I mean, it's flowing through you. Is it flowing through everybody?
Yeah, it's flowing.
Is it flowing through the entire universe?
No, it fills the universe. It is the universe is.
Okay. So where is it flowing then? If it's flowing through you at 11 meters per second squared, is that what you said?
Kilometers, yeah.
Kilometers per second squared.
No.
Where is it going?
No, not.
Is it going through you into the next person next to you?
Well, not squared. It's the velocity is kilometers per second.
All right. Okay. So 11 kilometers per second is flowing through you. Does it stop when it hits you?
No.
Or does it go right on 3 into the person next to you? If you're in a crowd, is it flowing through all of you?
No. It flows into the direction is into the center of the Earth. And as it flows through the apple, it drags the apple towards the ground, and that creates gravity.
Okay, and so once this flow gets to the center of the Earth, what happens to it?
It doesn't. As it goes into the Earth, it starts.
Okay.
As it goes into the Earth, it starts interacting with what we call massive particles that have mass.
Okay.
So initially they don't have mass, but as they interact with the ether, so the ether has the Higgs mechanism. So the Higgs mechanism of the ether endows mass onto the particles with which it interacts as it flows into the center of the Earth.
Okay, I'm still trying to understand what happens with ether as it flows into the center of the Earth. Where does it go?
It interacts with massive particles. It endows mass. It endows mass onto these particles through the Higgs mechanism, and it self-annihilates.
Oh, it annihilates. So where does it originate?
It originates. Well, So the ether fills the universe, and it flows into massive.
From where?
Yeah.
How did it originate?
Yeah, I'm answering the question. So the ether fills the universe, and it flows into massive objects. So very quickly, and it annihilates as it interacts with massive objects. So very quickly, the universe should have run out of ether very near its beginning. So right
One
after,
would think. Yeah. Yeah.
so right after the the initial Big Bang, the universe, all the ether should have gone into all the massive particles, and the universe should have collapsed on itself. So in order to avoid this, so Einstein added the what we call dark energy, the lambda, the positive pressure of the vacuum. So that's just for me, it's positive pressure of the ether. So the ether is always self-replicating. So it's always
Okay.
so it's always, I mean, this is just dark energy. So the ether is always creating a positive pressure. So a positive pressure of ether is always maintained in the universe. So that when the ether interacts with a massive particle and annihilates, so a local vacuum or a local low pressure of ether is created. And now you have,
So how does this replication happen?
I don't know. That's dark energy. Nobody knows.
Oh, okay.
I wanted to ask. Yesterday, you mentioned that there is energy associated with the ether.
Sure, dark energy, the quantum foam.
Okay, cool. So when the ether annihilates in the center of the Earth, when it flows in, where's the energy go?
The energy, that's just, I mean, look. So that's like asking the
That's
dark
a problem, isn't it?
No, it's not. So that's like asking when dark energy creates space and the space has non-zero state, because there is energy, the vacuum has an energy state, that is the quantum.
I thought you wanted to talk classical physics, so let's leave dark energy off to the side.
No,
let's
for
talk
me,
about
it's
your
classical.
ether. What happens when it flows into the Earth and it annihilates? But then what happens to the energy of the ether?
But it's completely, everything I'm talking about is completely classical. I converted
Yeah. So what happens to the energy?
Wait, who's asking?
I'm asking Tesoro.
Tesoro? Okay, just be
What's
nice.
What's happening to the energy?
Yeah, no, but I'll answer all your questions. Just be nice. Okay. So the energy, I mean, so when dark energy creates new ether, you're not asking where does this energy come from, right? According to the dark energy model, there's no conservation of energy. The universe is under no obligation to conserve energy, apparently.
Okay, so you're saying when ether annihilates, it does so without conserving energy. It just disappears. The energy disappears.
Yeah, apparently. I mean, I don't know
how much. How much energy?
I don't know, because you have the Higgs mechanism that endows mass. I don't know if the Higgs mechanism requires energy to give mass. I don't know.
How much energy? Okay, how much energy is associated with the ether? Let's say for a planet the size of Earth, how much energy is flowing into it in the form of ether?
I mean, so you just need to take the energy of the vacuum energy, the zero state of the vacuum, and calculate how much energy, how much volume is flowing into the Earth at per second, and that is your answer.
Okay, do you know the answer?
No, I didn't do this specific calculation. I mean, we can use F equals ma and F equals gmm over r squared. We can use A equals gm over r squared. So we know the acceleration of space everywhere in the universe due to a point mass. So that's how I got the 11 kilometers a second that space or ether is flowing into the surface of the Earth.
Okay, so what's the mass of ether then? Since you say that it's got energy associated with it.
No, I don't think. I see.
Well, what you're talking about is actually called the gravitational potential energy equation. That's the 11 kilometers per second. What you're talking about there. So that has a mass term in it. So what is the mass of ether that's flowing in for us to be able to calculate the energy?
Wait. A equals gm of r squared. That's the mass of the point mass. That's the Earth. The test
Sure, yeah.
particle doesn't have any mass.
That's the acceleration, but
Yeah.
you're talking about the gravitational potential energy equation. That's where you got your 11 kilometers per second of terminal velocity, so to speak. That is what you get. The velocity you get of a particle when it gets placed at infinity gets attracted to the mass, and at a radius of Earth radius, you're going to get a velocity of 11 kilometers per second. That's the thing that you were actually talking about yesterday.
That's funny. I never thought. Maybe I thought about.
Yeah.
this.
So it's called the gravitational potential energy equation. If you want to look it up.
I mean,
But
that's
that equation
wait.
has a mass term in it. That is the mass of the object that's falling. So what is the mass of ether that's falling in? We know its velocity. It's 11 kilometers per second. So what is its mass?
Well, I didn't use that equation. I just used A equals gm over r squared, and you just integrate A, right? You know the acceleration of a test particle, a massless test particle at infinity. You place it at infinity at velocity 0. Now you know its acceleration at infinity. So it starts accelerating towards the Earth, and you integrate over the distance from r equals infinity to r equals the radius of the Earth, and so but it's a it's a
When you do the
massless.
integration.
Excuse me.
Yep. And when you do that integration,
Mhm.
and among other things that you get out of it is the potential energy, gravitational potential energy of an object falling in. So you said that ether has energy associated with it. So I want to know what its gravitational potential energy is, and then where it goes. Well, apparently you already conceded that energy is not conserved in your model, which is going to be a bit of a problem.
Energy is not conserved, and we know the universe doesn't conserve energy, right? We know the universe keeps
Oh,
adding.
the jury's out on that yet. But
Well-
we definitely know that at small scales, for as much as we can test, energy conservation is a law of nature.
Right, but what do you mean? So, okay, according to my model, I need dark energy. I need a positive pressure, and this positive pressure, I don't know if it should cause the expansion of the universe, but I think we know that there is an expansion of the universe. So, what is the jury out on? I didn't get it.
We don't know whether dark energy is even a thing. It's currently a
Mm.
model that's being tested, but there's no
What-
conclusive evidence one way or the other. And the conservation of energy
Wait.
is as yet
Wait.
seems to be fairly accepted, especially at planetary scale,
Yeah, but I'm
which
told.
is what we call small scale.
Yeah, but I'm talking about cosmological scale. So wait, let's finish the
cool.
cosmological. What do you mean cool?
Cool. Just saying. Okay, so you've got all of the second law of thermodynamics is going out the window for you.
What do you mean for me?
Conservation of energy is going out the window for your theory.
What do you mean for me? For my theory, this is. I mean, dark energy. I mean, mainstream big physics agrees with me. I'm not saying anything
No,
against.
dark energy is as yet a placeholder, and we do not really know what it is, if it even is. So there's no currently accepted model for exactly what dark energy is supposed to be. It's just at best currently just a placeholder.
Okay, but everybody agrees the universe is expanding.
Yeah.
Everybody agrees the universe is accelerating its expansion.
That is so far not entirely sure.
The expansion is not accelerating?
There is some data to indicate that, but we're not entirely sure, and we're definitely not sure of the mechanism that's causing it.
I mean, but it's the lambda, right? We use lambda in GR, no?
Lambda is a possible method to achieve it, but we don't know really what it is.
But something is creating space in interstellar voids, right? Something is in the intergalactic or
Well, we don't know if something is creating space.
So what's causing the redshift, according to you?
The redshift might simply very well just be a function of the initial expansion of the universe. What you're talking about is the acceleration of the redshift at very large distances. We're not sure what's causing that, a possible explanation is that it is a cosmological constant, which might at microscopic levels be manifested as a non-zero vacuum energy. Yes, but we don't know. We don't know why that happens. And the amount, by the way, the vacuum energy at microscopic scale is predicted to be extremely tiny, like 120 orders of magnitude. You know.
No, I think it's the
down.
reverse. I think it's too big. I
Yeah,
think
sure.
when you use the vacuum energy,
You come up with inconsistent answers. Basically, yeah, it doesn't cancel. Yes. The problem is that what you're proposing is a physical object, not just a vacuum zero point energy. You're proposing a physical object that has definite energy associated with it. You've not described what the energy associated with is. You have not actually calculated it. And you're also not conserving energy in the small scale, which is a problem.
okay, so let's go step by step because I have answers to all the questions. So let's slow down. So so the truth is it's not so clear that the ether has a mass, because mass is endowed by the Higgs mechanism, and the Higgs mechanism is a mechanism of the ether. So the ether endows mass onto vibrations in the ether. So I don't know if the ether can endow, if the Higgs mechanism in the ether can endow mass onto Higgs particles. I'm sorry, onto ether particles. So I don't know if ether particles can have mass. I don't know. The ether particles, the ether fluid seems to be a fluid in terms of it limits the propagation of energy, for example, in the speed of light to a certain number. So it seems.
Just an FYI,
Mhm.
the Higgs boson does have a mass.
No, I'm not talking about the Higgs boson. I'm sorry. I did not mean to talk about the Higgs boson.
Okay, then don't mention the Higgs mechanism.
Why not?
Well, if you're not going to be using Higgs's model, then don't refer to it as if it was somehow encompassed in your theory.
Why?
Because otherwise, if you are, then you're going to have to explain other parts of it, or at least somehow incorporate it.
I mean, if I haven't done, I haven't completely built my model, so I can't.
That's fine. So don't call it the Higgs mechanism. Just call it the mass giving mechanism, according to Mr. Slave mechanism.
Yeah, but I want my model to fit what we know. There's no reason for me to create a new mass endowing mechanism because we already know we have an explanatory models. I just want to reuse that and just plug it into my ether. Why would I want to create a new mechanism? I mean, we know how it
That's
works.
because you don't get to just pick and choose bits of a theory just because you want them and ignore the bits that are required for the other bits that you've chosen. That's not how this works.
I'm not forgoing any bits. I'm taking everything. Along. I'm always saying that I'm complete. I am big physics compliant.
Cool. So you have the Higgs boson in your model in there somewhere.
Somewhere, I don't know. Honestly, I don't know how, but it should come out somehow. I don't know. I don't know how the Higgs mechanism. I know very little about the Higgs mechanism, but whatever creates the Higgs boson should do it with the ether. I don't see why not. However, they proved it. They've done it. So why would it not?
Yeah.
I don't see.
Then just trying to say that the Higgs boson does have mass.
No. But when I say ether, I don't mean the Higgs boson. The Higgs boson seems to be a wave, just like all other waves in the ether. But the ether particles themselves that make up the ether fluid, I don't see how they can be defined as having mass because they endow mass onto vibrations in the ether field. So
So
well, and yet that's what the Higgs mechanism says. Higgs bosons do have mass, and they also endow mass to other particles.
Yeah, but the Higgs boson is not an ether particle. In my model, the Higgs boson is not an ether particle.
Then what is it?
What do you mean? What? It's not an ether.
What is it? It's a part of the Higgs mechanism.
But
you say that you encompass the Higgs mechanism. So
yeah, but everything.
The Higgs?
The ether gives you all of quantum field. All of quantum field theory is right. The quantum field is the ether. The ether is that field in which all quantum phenomenon take place. It's just a mechanical. It's just a mechanical contraption instead of. I don't know what, instead of a vacuum. I honestly cannot understand when people say it's just a vacuum. I have no words. At that point, I just have no words. Why? I don't even know what that means. So I just don't know what that means. I just when the mainstream they say vacuum, I just say ether, and so far it just simplifies everything. So I use it. So my ether has the Higgs mechanism built into it. And sometimes if you pluck the ether correctly, you create a Higgs boson, but that's not an ether particle. An ether particle, as I said, I don't see how it can have mass. However, the ether does seem to have mass because it has a limit. It has a speed limit of propagation of energy through it. So it means it must have a mass. If the ether was massless, then we wouldn't have a speed of light. We wouldn't. I don't know. I don't know.
Good. So let's see some of your calculations that you've done to calculate that ether. I think you said you has to have mass.
Well,
so let's see some of those.
Well, this is just Maxwell. What do you mean, Maxwell? So according to this is Maxwell, and this is just
in Maxwell's model, the electromagnetic field, not ether, is propagated by massless particles, photons, that travel at the speed of light.
Right. Through the ether. The photons are vibrations.
The electromagnetic field.
Yes. And every time you say field, I say ether. I don't have a field.
Even a core field is ether.
No. Every time you say Maxwell's electromagnetic field or the electron field or the Higgs field, anytime you say field and when it comes to elementary particles and quantum phenomena.
Football field, baseball field.
No.
Cornfield.
No.
Soccer field.
Wheat field.
Okay, you're
dude,
now
Mr. Slade, it really sounds like you're just LARPing.
Gracie fields.
It really sounds like you're just LARPing, bro.
Tell us what LARPing stands for. It's an acronym.
Stands for Real Flat Earther Marty.
Anyway, if you feel that I'm LARPing, then find a contradiction in what I'm saying. Should be
there's plenty.
Yeah.
You've already contradicted physics in a lot of places, but
name one.
Yes, it feels like you're LARPing, but it could just be that you're actually LARPing.
Well, then
or
find
some kind of weird.
Find a contradiction in anything I said. Should be very easy if I'm just LARPing.
Well,
yeah.
Lucky for you, I've adopted your ideologies, and you are contradicting and non-contradicting at the same time.
Okay, so what am I contradicting?
No, you're non-contradicting, but also contradicting at the same time.
Fine, then you.
So
okay, so
whichever is the answer is the one I'm going to give you.
Okay, I don't understand what you're saying. So, anyway, Totoro, do you want to continue the conversation?
Not really. I'm already bored to tears.
Wait, who's laughing?
Holy.
Why do you call yourself Mr. Slave?
Yeah, I'd rather not discuss me. If you want to discuss
any topic in the universe.
It could be physics. It could be Mrs. Lave.
Anyway, does anybody want to talk about anything else besides me? Because I don't want to talk about me. So does anyone have any questions about my ether model?
But the irony is that you don't realize that's all you've been doing is talking about you.
Anyway, so does anyone have any questions about my ether model or about quantum mechanics or
No.
You know, nobody does.
No. I got a quick question, and this one has been, I've asked one guy this. Either way.
What? What did you say? Are you there? Hello?
Is English your second language?
I said I'd rather not talk about myself. So do you have any questions about my ether model or quantum mechanics or GR?
I don't talk to people who don't like tell me stuff about them.
I
So I don't talk to research
I'll make a
conclave.
I'll make a recommendation for you. Why don't you write this all up in a paper?
I did.
And
I
post
did.
it here.
I posted. And,
really?
Yeah, and what everybody did is they ruined the paper. I had to undo all the, all the mess that they created. So I'm not going to do that again. I'm not going to waste my time.
Does it have the math in there that you would need?
There's some math. I mean, I didn't finish. I just started writing. I was hoping to get some, normal human feedback, but instead I got, just, a lot of.
Welcome to Discord.
Yeah, my understanding of physics papers is that they have lots of math in them, and they come up with the equations that explain certain phenomenon that we observe. Now, if your paper, if your understanding doesn't have any of that math and doesn't explain the phenomenon that we observe, then it's not going to be very useful to anybody, right?
Sure. How would you quantify the nature and relationship of the aspects of what you're trying to impose as an idea without using, I don't know, maths or logical grammar in maths?
I mean, I just started, just 2 months ago, I came to the realization. The basic intuition of the ether does come out of Newtonian gravity. So there is a little bit, you need very little math. And when you figure out that Michelson and Morley should have received a null result, there is some math, very simple math.
If anybody says to me they want to smash a long-standing paradigm in science and they say you don't need much maths, I'm immediately suspicious.
Yeah, me too.
And with good reason.
Anyway, does anybody have any questions about my ether model? Does anyone want to disprove my ether model?
You don't have an ether model.
I have a question about your ether model.
Go ahead.
What is not in your ether model?
What do you mean? I'll tell you what is in my ether model very quickly.
No, everything is in it, but what's not?
Well, I'll tell you. I can go through. It's very.
You said you're mainstream, so we already know what's in it. What's not in it?
I don't know. Mainstream. All of mainstream physics is in it. I don't contradict any mainstream conclusions.
Okay. Then what's not in it?
I don't know.
Yeah, that's a good question.
I don't.
Or to characterize that question another way, yeah, right. And let's see where this goes. Okay, right. What doesn't your ether model categorically? What does your ether model categorically fail to explain right now?
Dark matter. I have a preliminary dark matter model, but I didn't stress test it yet. I don't know. I can talk to you about it if you want, but I didn't.
How would you stress test it?
I mean, I can present to you my dark energy, my dark matter model, but we could talk about it. But I don't think.
So does your model include any equations at all?
What do you mean? Like what equation?
Does your model have equations in it? Does it
No.
explain phenomenon?
It explains
Phenomenon.
My
Phenomena.
my ether model says that everything that we see is it's I'm just adding one more layer to the universe, which
Why?
it's a unified field. I'm giving you a unified field theory. I'm making sense out of SR, GR, quantum mechanics, Maxwell, dark energy, everything suddenly particle wave duality, everything.
You can't do that without having a lot of maths, there, can you?
Well,
You can't just smush words together and expect people to think you've unified it.
Well, go ahead, stress test this. Stress
Well,
test
I
me.
can't. There's no math. How can I stress test it? How can anybody
But
work
he
out the
just did.
limits?
I don't understand. I honestly don't
He
know
just
what you want.
did.
Anyway, there is a little bit of. I told you already. There's a little bit of math, and you said that's not good. So that's we're going in circles. I can't help you. I mean, it's a simple.
No.
It's a very simple theory that I basically just started working on, but it simplifies the universe for me. So if you want to hear it, maybe it will simplify the universe for you. I know a lot of people struggle with quantum mechanics and with GR and SR, and I don't struggle. I used to struggle, and once I came up with my ether model, there's no more struggle.
You're missing the point. Even if I didn't understand a word you were saying, I know enough about science and enough about papers to know that unless you are building, you can have a hypothesis, but if you're building your conclusions about such complex issues, which have a lot of maths imbued in them, and you don't build an interrelationship between those theories with an additional piece of maths, which either unifies or disunifies them, then I know that I don't have to listen to anything you're saying. Because you can't, you're building a house without bricks and cement, and you're expecting us to think you've got a glorious cathedral. Just because you said the words, I've got a glorious cathedral.
Anyway, does anyone want to actually have a conversation about my model?
No,
And
don't say anyway each time someone is.
I got a
trying to
question
raise
about your
you.
model.
Go ahead.
In your model, normal mathematics work like 1 + 1, correct?
Yes.
And what is 1 + 1?
Well, in general, it's 2.
Ask me the same question.
No. Does anyone want to talk to me about my ether model? Or about quantum mechanics, the wave function, Heisenberg?
I think you're gonna have to find your validation elsewhere, man.
No, I'm not looking for validation. I'm looking for
Yeah, you
I'm
are.
looking for
You are.
No,
No, you're not looking for validation of your theory. You're looking for validation of yourself.
No.
You're trying to put yourself forward as a person of purpose and meaning.
No, I'm
And
actually
you're doing it through this.
no. I'm looking for a stress test. I'm asking people to ask questions about my theory to maybe show me where I'm mistaken, where I'm wrong. Maybe I got it all wrong. So let's find any contradiction. Let's find where it's wrong.
You don't have any maths. We can't do that. Nobody can help you without the math.
I already told you there's a little bit of math. If you want, we could go through
No,
the
it has to
math.
be. It's almost all math. And if you don't understand that, maybe what you need to do, if you want some validation of your life,
I'm not looking
go
for
study
validation.
physics.
I'm not
Go to college.
not looking
Go to
for
a college.
Not looking for validation.
Study some physics.
You don't know
Learn
anything.
how physics is done.
You don't know anything about me. You're
I know everything I
assuming
need to know. I've heard you for the last half hour.
you don't
I
know
what I need to know.
you don't know anything about me. What you're suggesting,
Have you went to college and studied physics?
you don't know anything about me. So
Okay. Have you went to college and studied
I
physics?
don't discuss myself, but you don't know anything
I
about
know.
me. So you're welcome to
I
stress
know. I know you never studied physics.
How do you
I can
know?
tell that
How
from
do
the
you
way
know?
you talk
How do
about it.
How do you know? And why is it even
I can
important?
tell it from the way you talk about
Why
it.
is it okay?
We've already
Again,
outlined that, haven't we?
okay. Okay, whatever. So no one wants to stress test. Look, I'm just looking for anyone who wants to disprove my theory. Please, I'm here for you.
You don't have a
You
theory to
have no
disprove.
theory.
Oh, so what do
What's
you
your
mean?
theory?
My theory is that there is ether, as this universe is filled with ether, and everything we know as matter
That's not a theory.
and energy in this universe, these are just waves in the ether. So all elementary
Not a
particles.
theory.
Okay, what makes you think that?
That's not a theory.
No, you
That's
see,
fine if it's not a theory. I'm wondering why he thinks that's the case.
One second, let me lower your volume because everybody else is like normal, but you're yelling for some reason. Sorry.
You are kind of loud, demonstrating.
Yeah, I lowered your
Strong.
volume.
in what sense don't you think this is just merely a hypothesis at this stage without the math?
1 second. So Demons tried. You were asking, what is my theory? What did you ask?
No, so you explained your theory, and I'm asking why you believe that theory to be likely.
Okay. So, I mean, everything. I mean, what mainstream science or mainstream physics, they use the word vacuum a lot. They say that electromagnetic radiation waves through the vacuum, and the quantum field is a field of vacuum, and dark energy is the expansion of the vacuum. And so
This is all leading to why you believe your theory of ether to be true. I'm just curious because you sounded like you said because mainstream science says this, and this about these other topics. You're now getting to a therefore ether. Just please tie that up for me.
well, so mainstream physics, they say vacuum, but vacuum means lack of. Like when you vacate the premises, you're no longer there. So a vacuum is
Evacuate the bowels.
So a vacuum is a lack of. To claim that like in Maxwell's electromagnetism, the vacuum is waving, that's a contradiction. A wave.
So it's a semantic. Your theory is based off of semantics and how words are used in sentences. Your theory of reality is based off of semantics. That's what I'm hearing.
I mean, it's not semantics. I mean, to say that there is something.
No, it's definitely semantic.
So then
So why is ether likely? Because now we've gotten to the crux of it, is that the word vacuum is postulated, but a vacuum can't be this quantum thing because it means to evacuate or to be nothing. And is that really what is that kind of what you're coming down to? Because that's what it seems like.
It's not just they. It's like I used to be them until 2 months ago. If you would have asked me, I would have spoken just like you're speaking.
Well, they can't do anything for your theory. Okay, so your theory of ether should not be contingent on what they say, right? So why don't you just explain why you believe that ether in your theory to be reality versus, you can just leave what they say out of it because that has nothing to do with your theory.
I lost you. Anyway, so until 2 months ago, I used to believe just like they taught me, just like, mainstream physics taught me, that the universe is empty, and just like Einstein said in his
To what level did they hang on a minute? To what level did they teach you? Are you talking about what you gleaned off of YouTube and the internet yourself without any, or were you academically trained? Did they actually teach you?
Your understanding of what they say is not them teaching you, nor do they say the universe is empty. Like, your misunderstandings aren't our fault or their fault either.
Nor do they say a vacuum doesn't contain anything. Did you say a vacuum is essentially devoid of physical matter?
Look, so you have to decide, is the universe like electromagnetic waves? Do they wave in a vacuum or do they wave in some ether?
In a field.
What do you
They wave in a field.
No, they wave when they're leaving. They're waving goodbye.
Yeah, they wave when they say goodbye, when they say hello.
No, what are you saying? Are you saying that electromagnetism doesn't take place in a vacuum? The effects of it?
No, he's saying a wave, is it waving
then he's using it as a verb. Like, is the flag waving? What's with that photograph? Oh, it's the wave of the flag. Oh, well, look at it. It's waving. Yeah, excuse me, but electromagnetic fields, electromagnetic waves are not the waves of a flag or the surface of a body of water in wind.
Like I said, he's using his argument is semantical. He's using semantics to prove physics. Good job, sir.
It's reminiscent. It's reminiscent of flat earthers saying level is a straight line because they use the word level.
This Mr. Slave guy is like research concave Earth and yaw angle mixed together with a shitty foreign accent.
Anyway, so going back to electromagnetic waves. So is something waving, or is if there's nothing there?
Again
then
with the verb.
Is it a
Again with
frequency?
The verb. Why are you using an adverb to describe something?
You mean a verb?
Are you saying EMF, electromagnetic fields, frequencies? Which one is it? Are we talking about light, photons, waves?
Look, right? So you place a charge. Let's evacuate the universe of everything, and let's now place a charged particle at the center of the universe. So you agree that within the speed of light, let's say at a distance 1 kilometer from this test particle, I have a detector, an electric detector. So you agree that once I place this particle within however much time, let's say a light year, let's say I put the detector within a light year of the test part of the charged particle. So I put a charged particle at the center of the universe, and a light year away, I put a detector. You agree that it's going to take a light year, or it's going to take a year until the detector will detect the charge, right?
I say no.
Wait, okay. So how much time?
Well, first off, tell me the speed of light, because the science is still out on that.
Okay, but does anyone want to answer the question? I'm asking a simple question. Like, does anyone know?
If a particle of light appeared a light year away from the detector, it would take 1 year for the light to get there. What's your point?
No, it's not light. I said electric field. Let's say I place an electron. Let's evacuate. Let's have a thought experiment. Let's evacuate the universe of any object. Let's put an electron at the center of this universe, and a light year away, let's put another electron. So let's first put the detecting electron a light year away, and now let's place so electron, let's call the testing electron is electron 1. It's a light year away. And now let's place electron 2 at the center of the universe. Now they're a light year.
Any two. We get the point. Any two places a light year away. We just say that, yeah.
Yeah. So
And what's it like?
how much time would it take the detecting electron 2? How much time would it take until it detects electron 1?
Do they interact?
I mean,
how do they interact with each other, and how is it? Because if it's not visible light, it's just an electron.
It's just an
What is it?
electron, right? But
Okay,
we know.
Is it, are we using magic right now, or what's going on?
No, we're using Maxwell. So you have, look, let's say you have 2 electrons next to each other, right? They repel each other according to Coulomb, right?
Okay, so you're looking for the Coulomb
Right.
force, right?
But how fast does Coulomb travel? So I'm placing them
Speed of
now.
light.
Okay, why?
That's because that's how fast the disturbances in the electromagnetic field fly or propagate. That's Maxwell's equations.
Right, but
So
why?
when you're
Why does it propagate at a speed? Why is it not instantaneous, for example?
in our thought project, is the universe expanding at a rate faster than the speed of light we speak of?
No, no, no.
Oh, we're
So
ignoring that. Okay.
going back, okay. So why is Coulomb's law traveling at the speed of light? Why is it not instantaneous?
Well, let's describe it more accurately as the speed of causation.
Yes.
Fine. But
all causes and effects are separated
I'm not
by a speed.
I'm talking about
speed limit.
I'm talking about two electrons. Let's concentrate. I want to simplify the problem. Let's make it about
Yes.
two electrons and Coulomb's
Okay.
law.
Cause the electron. The effect being a repulsive force. Yes.
Yes.
Separated by
But they're a light
the speed
year.
of light.
Why? Why is it the speed of light?
Well, apparently that's just the speed of causality in our universe.
No, no, no,
It
no,
appears to
no.
be
There's
universal.
only no.
Are you asking us because you think you have an answer to this, or are you just asking us?
I mean,
because
I
you
mean,
don't
for
know?
sure. I mean, of course. I mean, you're unable to
Just
answer.
get to it then. Just get to it.
Okay, so here's the answer he's looking for. There's no medium surrounding the photon on the other side to jizz on. Hence, it's not going to propagate itself to see anything in front of it.
I don't know what you just said. Anyway, so look.
Well, come on then, explain to us. Explain to us why you're asking that question.
Because you don't have an answer. You don't
No,
know.
no, no. You're giving us your answers, okay? Don't quiz us. You tell us your theory without trying to make us do the work for you. What is your theory? Summarize it without asking us. It's not a quiz for us. This isn't a pub.
Holy rage! Look how mad he is. He doesn't know it.
2 points a person. Just tell us what you think you know.
Well, I'm using
Please don't interrupt.
I'm using the Socratic method. So I'm trying to lead you to where I arrived. So I've already
don't do it by
tried
quizzing us.
No, 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 I'm not quizzing. I'm using the Socratic method because I already gave you the answer many times and you reject the answer any which way I try to give you the answer. So now I'm trying to use the
I've not
Socratic
heard an
method.
answer.
Oh, I've given
Yeah, I haven't either. I've been listening to this shit for days.
Please, teacher, tell us the answer.
Anyway, look, the question is, I have two electrons a light year apart, right? So let's say the one on the right is we call the detector. We put it there first.
Holy shit! You did this 10 minutes ago. Can you like wrap it up, please?
Well, maybe you understand, but I don't know if everybody else understands. So on the right,
Everybody else understands. Stop repeating yourself over and over. Be done or move on.
Yeah, everybody understands. Let's carry on.
Okay. So look, I asked the question, why would it take a year for the detector to be influenced by electron 2? Why would it take a year? Why not instantaneous?
Yeah, good question. Answer. What's the answer?
Right, but you don't. The point is, you don't have an answer.
Okay, carry on. Yeah, give your answer. Okay.
What?
Don't quiz. Give your answer. Don't quiz.
No, I'm not quizzing. Look, and I'm saying, you mainstream physics doesn't have an answer to this. It's fine. I'm just saying.
Yeah, sure. Now give your answer.
So the answer is that there is a fluid that the ancients called the ether. There is a fluid that is an electromagnetic radiation, an electric field, magnetic field. It propagates through this fluid, and the propagation of waves
Say
in this
medium, bitch.
And the propagation of energy or information or perturbation or waves in this fluid, the maximum speed that we know of happens to be what we measure as the speed of light. So it's a mechanical wave, and that's what Maxwell.
You said fluid. Is it moving? That's the definition of usually we talk about fluids and fluid dynamics. Is this fluid moving in any particular way?
It happens.
Or is it completely stationary?
It happens. Because my ether is a unified field theory, so it's also gravity. So when it comes to gravity,
just smushing words together, aren't you?
Excuse me.
It's fluid. Define the fluid. Is it moving? Is it stationary?
So I was answering the question. So if you let me finish, I'll give you the answer. So my ether is both luminiferous, meaning it is Maxwell's ether. It allows for electromagnetic radiation to travel through it as the medium, but it's also the medium of Newton for Newtonian gravity and Einsteinian general relativity. it is the medium by which the apple accelerates towards the ground. So when the ether flows towards the center of the earth, it drags everything along with it, and that is why the apple falls towards the ground. So yeah.
Right, so it has a flow. So does electromagnetic do electromagnetic propagation take place at different speeds, going away from the Earth as opposed to towards the Earth?
Yeah, definitely.
Yeah.
Yes, you can detect.
Interesting.
Yes.
You got any proof of that? Got any measurements of it?
I mean, I am in the process of writing a bunch of papers. One of them is a vertical interferometer. It has to be very big. We're trying to detect 11 kilometers per second towards the center of the Earth. Is
it happen just towards the center of the Earth, or does it happen towards the center of other bodies? And is the Earth in your conceptualization a spheroid, or is it flat?
No, I'm a normal physics person. I'm completely mainstream.
Okay, so does this flow occur towards the center of the sun and other bodies, or just the Earth?
Yes, it is gravity. It is Newtonian. It's completely described by GR and Newtonian gravitation. So I'm not saying anything new. I'm just adding a unified field theory to all of physics. I'm just unifying all of physics under the ether.
So it's just a verbal placeholder you've got.
No, it's a mechanical contraption that is at the foundation of all of the universe.
And how does it manifest itself in a way that you can evidentially check or measure?
So if you want, you can have to detect the 11 kilometers per second flow into the Earth, you can have a vertical interferometer. You can also detect horizontal motion, but you would need a 10-kilometer arm interferometer. That's why Michelson and Morley got the null result. It was just way too small. They were looking for 30 kilometers a second motion of the ether, but in Ohio, I think it's 300 meters per second horizontal. So they were off by 100. So instead of 10 meters, you need 10 kilometers.
So the Earth in your model doesn't move about the sun?
Yes, it does. I'm completely mainstream.
Then why wouldn't you sometimes detect 30 kilometers per second?
There is no, because the ether flows mainly at the surface of the Earth. Most of gravity is towards the Earth. When you think of the ether, think of gravity, like gravitational ether. You have to think of gravity. Right now, Earth is dominating as you're sitting in front of your computer. So Earth is dominating gravity. There's a little bit of gravity maybe from the moon. You might be able to detect that. Mm-hmm.
But you said you could just from the ether flow, you detect the movement of the Earth and your orbit around the sun at the same time. Yeah.
I didn't understand what you said. Could you please repeat?
You just said you better detect the motion of the Earth around the sun using by your hypothesis.
I didn't say that. I said
I was asking him.
Oh,
I said you can. So right now you can detect gravity, right? You drop the apple falls. So my calculations show that basically the ether flows at 11 kilometers per second towards the center of the Earth. So if you build a vertical interferometer, I think it has to be about 300-meter arm, which is big, but there's a way to shorten it. I've come up with a way to build a small interferometer. So
did you say that Michelson-Morley's experiment was too short? They'd have made it longer. There would have been to detect the motion of the Earth around the sun.
Yes. What? No.
So you can use it to detect the motion of the Earth around the sun. Then.
No. Horizontal.
No. Okay.
No. The ether, you can detect the motion of the ether horizontally because of the rotation of the Earth. Nothing to do with the sun. There is no ether wind the way they imagined it. Their ether was just luminiferous. My ether is everything. It's luminiferous, meaning it's Maxwell's ether, plus it's Newtonian, it's gravitational ether, Plus, it's quantum mechanical. It's a quantum field theory ether. It's a unified field theory. It unifies all of physics. So there is
So
no.
how could if it's all wherever you are, it's moving 11 kilometers a second, I believe you said, towards the center of the Earth from every
Yes.
direction. Yeah.
Excuse me.
How is
Yes.
it perturbed or altered by the motion of the Earth, so that it's such that you would detect that in the ether flow?
So imagine vertical lines of ether. Imagine a rain of ether raining towards the center of the Earth. But it doesn't know, the ether doesn't know that the Earth is rotating. So if you're at the equator, you're moving at 1,000 meters per second towards the east. So basically, the ether is raining on you vertically at 11 kilometers per second, but it's also moving horizontally at 1,000 at a kilometer per second. So basically 1 to 100.
Why is it
1
moving
to 10.
horizontally?
1 to 10. Anyway, what? Why is it horizontal?
So it's not. So it's actual speed. If it's moving, if it's always moving towards the center at 11 kilometers a second.
Yes.
And the motion of the Earth as a consequential another vector of motion on it, which
Yes.
depends on where you are.
Exactly.
It's not always traveling at 11 kilometers a second in total, is it?
Well, it's always 11 kilometers a second vertical.
Right. Yeah, this sounds airtight.
What's the question?
Concave Earth loves the ether, by the way, Mr. Slave. You're doing great work.
Fantastic
Concave Earth
work.
commends you. Carry on, please.
Concave Earth gives many, many thanks to you.
Wait, so do you have any questions? Did I answer all your questions?
Yeah, really, you did, yeah.
Does anyone else have any further questions about my ether model and how it answers basically all of physics? It explains all of physics. It's a very powerful theory. Has great
Yeah, can I
explanatory.
ask you one last question? Okay, right, yeah. What makes you think you've come to this, and 2 millennia of geniuses haven't come to this before you? What certain pizzazz or smazz or snazz do you think you bring to the table that no one else has? It's complete. Everyone's completely overlooked.
That's
it.
an ego-based question.
What is it?
It was absolutely is. It's nothing to do with the
It's
information.
an ego fallacy.
It has to do with his ego, and you're basically self-projecting onto him. That's what you're doing.
Why? I'm
Yeah.
not making any claims.
It doesn't matter.
I know that lots of people have studied it and made claims, and none of them agree.
Okay. Look, I'm not
why
going
would I-
I'm not going to respond to any topic other than the universe. I'm not
Are you
talking.
a real person?
I'm not
He's
gonna.
prepared to in any way.
I'm not gonna.
offer a mechanism of veracity for what he says, which is fine. That's what I'd expect from someone who hasn't got one.
I'm not going to discuss myself. So
Of
if you want to
course.
discuss,
Can you break your loop? Like stuck in a loop.
what?
Are you able to answer other questions beside your magnificent theory about the ether?
I've said I'll gladly discuss any topic in the universe except for me. So you're welcome to ask me any question.
So I asked you, are you a real person?
That's me. So I don't discuss me. So try something else.
Do you understand something about cars?
That again, you're asking about me, and I don't discuss me. I want to discuss the
I'm
universe.
asking about your knowledge. I'm asking you to describe me how a car works.
You want me to explain to you how a car works?
Yes, you're such a magnificent physicist.
Please,
can
please don't
explain-
bother our guest here with these questions.
You want?
Let's just stick to him telling us stuff.
Well, do you have any questions about my? I mean, if
well,
you
I can't. We can't ask you questions, so you just carry on telling us stuff.
I'd rather you try and stress test my theory. Anyway, so
Well, there's nothing to stress test. You haven't presented anything that's robust enough to be stress tested, other than me saying to you, "Have you got any mass for it? Have you got any measurements for it? Have you got anything that corroborates other papers or that you built this on as foundational? Have you got anything that takes it from the very loosest sense, the hypothesis, and actually makes it into a theory proper in the scientific vernacular?"
Mr. Slave, I think I understand what you want from the room. You know, you think you're engaging with a group of intellectuals that are on the cutting edge of intellectualism, and they have
He
an
doesn't think that.
esteemed gentleman like yourself presenting information, which is great information.
Jesus Christ, Glory, get off his
And
cock.
Yeah,
and
and,
you
and then
think
and all glory comes in with his
listen to them
wrecking
disparage
ball.
you,
Yeah,
Mr.
thanks.
Slave. So as I was saying, you
Glory,
Yeah,
you're
as
wrong.
you
He
were
doesn't.
saying, Mister. Yeah, go ahead and finish your derpiness, but we don't need concave doing that.
Yeah, and
there.
he doesn't think we're
I was
luminaries.
in the middle of my
He
sentence.
doesn't.
Please
He
let me
doesn't think
finish.
we're
my
luminaries.
You were in the Glory. middle of grandstanding,
I
Glory,
was in
and
the
you're
middle
just
of
interrupting a
speaking to Mr.
conversation.
I'm not involved
You,
in
you,
y'all's
you,
debate. Let me speak to
yeah,
Mr.
you were
Slave, please.
you're just grandstanding. We don't want to hear it. We can go back to the conversation.
It is what it is. The owner of the server is not here, so
It is what it
do what
is.
you got. You're basically doing
Take a
what
seat.
killed your server. You know that, right?
Take a seat, Glory. Let's go back to the conversation they were actually having.
Wait, why do you call him Glory?
He used
That's his
that
name.
name.
His name is
I mean, really,
Insphere.
what I was pointing out is you're going to need some substance behind it, aren't you? Other than just.
Hey, Mr. Slave, at a better time when we're less gate kept by the Glovers, I'd love to discuss more into your theory of the ether, and maybe I could bring out how the concave Earth tries to explain it, and just for fun, you know, because that's what intellectuals do.
Oh, please do.
So
Yeah,
I did
just-
enjoy listening to you. Thank you very much.
You can DM him
Have
if
a great
you want him so much.
Please do, all glory. Do go on talk about your ether model on concave Earth with Mr. Slave here. That'll be extremely entertaining to listen to.
He's wherever he is, whatever he says that every time, but all he ever does is come and do puffy, chesty grandstanding. He never talks about his own model. It is what it is, isn't it,
Because he
Glory?
doesn't have one.
No, it is what
Glory
it is.
just wants to grandstand. It is what it is. Yeah, you're right. It is what it is.
So do
Yeah,
you?
I mean, you're going to need a bit more than that, Mr. Slave. You really are. Not so much because you may convince me in my naivety or someone else on Discord, but that's one rung on a very long ladder you've got to get to the top of, isn't it?
Sure. I mean, look, there's many questions in my model. I mean, for example, like in my model, so I can give you the weaknesses that I've already encountered, even on this server, that people have asked me questions that I don't have an answer to and have bothered me since the beginning. So in my model, the electron is a wave packet that cannot be broken in two. Yet we know that it goes through two slits. So it must be breaking up as it's going through two slits and interfering with itself. So I don't know. So I don't know how the electron does that. That's something I don't know. So that's a weakness of it's not really a weakness of my theory, since big physics certainly cannot explain the double slit experiment. But I'm go ahead.
Have you discussed this with anybody within academia at all? You know, on a first one-to-one basis. Have you put any papers into? Well, your old dean or your old faculty, they must have some connections, because wherever you studied physics, they must be able to put you in the picture as to who you could talk to about this.
This is the first time that I'm discussing this. This is I mean, I've made videos.
Why on earth, if you got this knowledge, why on earth is a group of blokes on Discord of various levels of competence in this? Why is this your go-to?
I was invited by the server owner. I mean, we had a discussion like 2-3 days ago, and he was very excited about this model.
So was it your first time 3 days ago, or is it now? Because it sounds like you've been talking about it for a while instead of just now.
No, I've been talking about it for like basically 2 months, 3 months on YouTube on my channel. But a couple of days ago.
So what's the next stage in the plan? How are you going to escalate this to well, dare I say, a global audience?
I don't know yet. I mean, I'm still, as you can see, I'm just struggling to get people to stress test my minimal intuitive theory. So But really, what I need, I presented the server with a bunch of papers, but I got only nonsensical comments. But I mean, me and Liongate or Sea Lion, he asked me to start working on the papers so that he can read them. And so,
Why don't you?
Mhm.
Why don't you find someone in academia and give it to them and ask and say to them, look, I've got this. I'm very passionate about this. I think this is quite important. Can you just give it a run through, see what you think? Have you got any comments? Actually, if you want to stress test it, pass it to someone who can genuinely stress test it. It's got a proven track record of being able to stress test it. Rather than I don't know, people in here they may have more or less of a knowledge than you. I don't understand quantum mechanics.
When you go
as much as a lot of people on here.
When you go to YouTube and you listen to the big physics science educators, physics educators, one of the things they tell you is they tell you that they get enormous amounts of emails from people like me who have a unified field theory and proof of why Einstein was wrong. So these people get inundated by basically people like me. So
what does that tell you? Does that tell you anything at all?
What does it tell me? I don't know what it tells me. I mean, there's some YouTube channels that I listen to of people who are like, basically, you could say like me, who are, you could say revolutionary. I listen to them, and
Do they think they spend? Do you think that those same people are inundated with PhD physicists with opposing theories? Do you think they're inundated by those sort of people? Is it just people who haven't gone through academia that they get inundated with these theories?
Some of them, like if you go to some of these science educators, they don't say that a PhD, that you become immune to being a crackpot if you have a PhD in physics. I mean, some of the people they talk about have PhDs in physics.
Have you ever
So
worked with
you're saying these emails then are mostly crackpots. In other words, because what I'm hearing in your description is very much like a Terrence Howard approach.
Yeah.
For the record, my first job, I worked for 2 years in university, assisting PhD and postgrad faculty researchers and people working in both in academia and industry, working on various material sciences projects, including stress mechanics, white noise, and all the PhD people I met were fucking mental.
Yeah. So having a PhD in physics, I don't know if it makes you immune. I don't know. I honestly don't know. Maybe it does. It's just another
Well,
filter.
I don't think it makes you immune to creativity. I was working with people who were building Polaris missile launch systems on nuclear submarines that were perturbating inverse vibration mechanisms to stop the launch from shattering contingent components of the submarines. This is going back to in the early 90s. They were working on white noise systems in aircraft to cut down on propagated noise from the engines of the craft, to make it more comfortable for and they were working. This is working in racks of 386 and 486 CPUs, a long time before there was anything hefty going on. Other people working, they were all very massively creative, all being used by the motor industry, the aeronautics industry, using some of them working on the cutting edge material sciences, semiconductor sciences. These weren't stymied zombies. These were people who are driving science forward.
Well, what's your
Why would
point?
anybody characterize someone who reaches that level as being somehow docked or muted or neutered or zombified? Why would you do that?
No, not me. I'm just telling you. I just listen to YouTube science educators who are actual, PhDs, and they teach, very good physics, and I learn a lot from them. And then they complain about some professors. Some of them are Harvard heads of departments. I'm not going to mention names. They complain about them that they are crackpots. So
some people bitch that some people aren't any good.
Whatever. Look, the point is, it's not like I'm going to be immune to being called a crackpot because I do or don't have this or that degree. So look, I have a theory right now. I'm spending a lot of my time studying physics because I'm curious and I want to complete my theory and I want to complete my papers. And in the meantime, I am looking for anyone who is willing to listen. I don't care who you are. If you're willing to listen and try to understand and ask me questions, that's all I need.
That's no good. That's no good to you, Mr. Slave. If you're working on the cutting edge of science,
Mhm.
coming into an audience of people and explaining it
Mhm.
without any math and just saying, "Well, I think this and I think that," you literally just a train of sentences. People are going to sit there and go,
I
"Yeah,
submitted
okay then."
I
Yeah,
submitted
right.
papers.
That's not stress testing anything.
I
Other than other
submitted
people's patience.
I submitted papers to this server with some math, and all I got in response was ridicule and garbage comments that no one
Well,
read.
maybe
No one read anything. So look, the point is, if you want to stress test, if you want to talk about my theory and ask me questions, like what I just said, you want to help me solve how the electron goes and splits but doesn't split. How does it manage to do that? You want to talk about that? That's fine. If you want to talk about what is quantum spin, that is something I'm very curious about. I have not figured that out. How do these wave packets maintain integrity and not fizzle out? Why are all electrons identical? I'm curious about these things. So if you want to talk about these things, I'll gladly, because there's many things I need to think about. Yeah.
I don't think that's the approach you want, mate. You want to go and find someone who can actually pull it apart properly, don't you? Well, why? I mean, in my field of technology, I'm working on capacitive touch technologies and noise propagation through them, including moisture earthing and these sort of things for mobile phone telecommunications. There's no point me putting some ideas together and going down shouting at the top of my voice at the fish market and hoping that one of the fishmongers is going to be to put some answers. And I'm not stress testing it if any of them go, yeah, all right, fair mate, that sounds fair, mate, or one that goes, fuck off, this is a fish market. What are you talking about? That's
No.
not stress testing anything I'm saying, is it?
No, that's not my experience. My experience, I've spoken to, I mean, on this server, I'm making very little progress. Most of the time is being wasted. But when
So why are you banging on about it then? If this is redundant
let me
in terms
just,
of your stress
let me
testing,
just,
why are you continuing the stress
let
testing?
me just finish my sentence. So like most of the work that I did, most of the progress was while, I mean, there's YouTube videos, there's recordings. It's usually doing conversations with normal people. Like most of them are children, like middle school, and they ask good questions and they bring up, just very simple objections, and they stress tested my theory in the beginning. And I thought, I was invited to this server. I thought, I was told on this
You
server there's
stress test little kids. This is what I hear.
Mr. Slave, you're telling them this, in the hopes that they will do better, but they're not going to do better. They're
know.
just going to keep questioning. They're going to reject anything that isn't in line with their belief system. That's
Glory's
how it is.
I know.
Glory's about to hypothesize how this manifests itself in his model, ain't you, Glory?
Anyway, I don't want to waste anybody's time.
Hello? Oh,
I don't want to
Glory's mic's
waste.
not working for some reason.
I don't want to waste my time or anybody else's time. So I'll just leave for now. Thank you. Have a great rest of your day. I'll be back later. Anyway, these people are absolutely horrendous. Where's that guy? Let me talk to that guy. Where is he? This guy. Oh, he didn't. Oh, we are friends? Research concave? Let's go to my server. Okay, because I'd like to talk to this guy. This guy is is he coming? Why is he not coming? I can come at another time. I'm a little busy right now. Okay. Hey, I just wanted to. I just wanted to say, if somebody wants to come to my server and have like a normal discussion, you're welcome. Bye.
So
Anyway, what do we got? So let's listen maybe a little bit more to this guy. Oh, this is not the guy. That's me. That's mine. We're gonna need to go back to this course because I'm lost at this point. Why is there a cosine theta when isn't theta 45 degrees or something? Why do you have a theta here? And why is the answer? I don't get it. Yeah, I'm gonna need to go back and review this because I'm getting lost. This guy. Let's see what else he has to say.
Islamic scholar, effective public speaker, and competent organizer. This is a guy who claimed the Holocaust is a myth. That throughout history, the Jews have been Allah's most cowardly and avaricious creatures.
1 second. There is a message. Misinformation.
If the Jews all gather in Israel, it will save us the trouble, he said, of going after them worldwide. This is the Islamic scholar, effective public speaker, and competent organizer that the Guardian identifies. So that is the world media. That's the left. That's the global left. The global left is just enamored with this guy. They love this guy. They're obsessed with him. I haven't gone and looked to see what Tucker Carlson might be saying about Nasrallah. He might be staying quiet. He doesn't want to support a loser. But
1 second. Let me see. There's another message. Why do you this? Why do I this? It is getting sad. Come to my server and let's talk. Discord. Nope. Doesn't want to talk. All right.
But this is what global left supports. This is what they what they like. There was also a student group. There was the Penn student group had this amazing statement. Let's see if I captured it. Maybe I missed it. But yeah. This is from UPenn, Students for Justice in Palestine, and they've got this morning of Nasrallah's death. When a leader departs, another rises. His soul departed to join his fellow martyrs, resisting until the last moment. While we today feel the bitterness of loss, we stand tall and facing his enemy, who thought that targeting the leaders would break the will of the resistance in people. On the contrary, the ranks of the resistance in Lebanon and everywhere. Hopefully, these kids will actually go volunteer and become part of the resistance. That will dealing with them here a lot easier. The blood of these martyrs will form new fuel for the fire of resistance, which will not die until the liberation of Palestine and all occupied Arab lands. This is a quote from Nasrallah. Just as I always used to promise you victory, I promise you victory once again. Hasn't worked out too well for him. Anyway, those are your students on campuses today. In addition, you've got 17 members of Congress, Democrats. I think all of them. Is that true? They're all Democrats. Yeah, every single one of them is a Democrat. One independent, Bernie Sanders. All of them have joined forces to call for an arms embargo on Israel. Now, 2 of them have lost their seats already in the House of Representatives. But you got Bernie Sanders, Jeff Meckley, Peter Welch, Brian Schatz, Tim Kaine, Democrat from Virginia. That's in the Senate. That's 5 senators, 5 Democratic senators, and 12 Democratic congressmen calling for a arms embargo on Israel.
Oh my God. Where is it? This guy? Hey. Someone wanted me to come back. Misinformation agents.
Yes.
You want to talk about something?
Ask you a simple thing. You want to present new theory about physics.
No.
Why wouldn't
That's
No?
no. I didn't wake up one morning wanting to invent a new theory of physics. That's not what it's actually recorded. You can see exactly how it happened. I was doing a video review of Veritasium's video on black holes called something.
No, I don't want the background. How did you achieve it right now? I want the logic. Okay, want to achieve something. Why don't you take the road which people take to achieve it? Like actually learn, but not from YouTube. Real learning.
What do you mean real? I'm doing right now. I'm learning the Dirac notation. Why does it matter? Like
No. What you need to learn first of all is math and physics.
Why do you think I don't
real
know?
physics?
What?
Not your imaginary ether physics. So you can falsify the physics and then to claim you have an ether, right?
I don't understand. Right now, I'm going. Right, when you go to university, you register, and let's say sometimes you go to class, but sometimes you have online pre-recorded videos. How are these online pre-recorded videos different than a YouTube video, a YouTube video playlist? How is it different? Are you there?
This is a good question, okay? But you, as a person that doesn't know the field currently, and we hear it when you talk, you need a structure. You cannot jump between courses like you do, and hearing you talking about only 2 months and jumping to higher level subjects, I would assume you need a background because you
Ask
don't
me.
understand.
Why don't you ask me a
right
question? Ask me a question in physics or in math.
I don't need to. Apparently, you presented some type of paper.
You're
The
you're
guys
you're telling
split
me
it apart.
you're telling me to go study physics. So what do you want me to learn? Ask me a question. Ask me a question in some
I
physics or
want you to learn everything from
name.
start.
Give me an
okay?
example. Give me an
Like
example.
a normal person does.
Give me an
it
example. Give me an example. Give me an example. What do you want me to learn? Give me an example.
Again,
Just give
I'm
me an,
not your tutor. I'm not your tutor.
just give me an example.
Just giving.
Why is it so
I'm giving
difficult?
you
Why is it so
a
difficult?
general.
No
a
general,
general
no
advice.
general, no. Give me an example. What do you think I need to learn? What do you think I need to study? Give me one example.
First of all, you need to learn how to be patient and how to talk with people because I'm trying to say something and you're breaking me. Okay. The whole thing I said you trying to break the known knowledge, you need to start from the known knowledge. And when you just see a video about some concept in physics, doesn't mean you actually understand it.
So why
If
don't you ask me a
want to-
question? Why don't you test me right now on any topic? Don't waste my time. Ask me a
Can you
question.
explain the second law of motion?
F equals ma. F equals dp/dt.
Explain.
Sure. I mean, it's a good question. I mean, I don't know. I was actually there is this.
How do we derive?
That's exactly what I was looking into. I mean, how do we derive F equals dp/dt?
Exactly. If you studied math or calculus, then you went to physics 1, you would know, you would understand the logic behind our conclusions.
No, the
we
logic.
use, and
no.
then we can use them.
No, I've used it many times, but the question is how to
No,
derive
you
it.
didn't. No, you didn't.
Well, you're
You
asking me.
cannot
Wait, you're asking me to explain it or to derive it? What do you want me to do? Or to use it as in an example?
First of all, I
Do you
asked
want
you
me?
for the
Do you
definition, not the formula.
the
Can
definition?
you
What do you mean? The
explain?
definition of the
Explain.
second.
Okay.
Let's go step by step.
Yes.
Fine. Let's go
What
step by step.
is the second law?
Fine. Let's go. The
What
second law.
is?
I think it's. I mean, the first law is the law of inertia, and the second law is basically also the law of inertia, expressed a little bit differently. So, force causes a change in momentum. dp dt. So you have P1, P2 minus P1 over T2 minus T1 is equal to F. So whatever.
No.
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 You need to.
Mm-hmm.
I don't know. Find better courses, better teachers.
Better than what?
And simply go and actually learn the stuff that you are trying to talk about. No one is here to teach you those stuff. And no one wants to hear a theory from a guy that can speak of the basic.
I'm curious, how would you answer the question? I mean, you asked me to explain F equals dp dt, and I think I was beginning to explain. No, you don't want me to explain. So what's the question?
Why you even say that?
So what's the question?
F equals ma.
No,
okay?
no, that's not. No, Newton never said F equals ma. That never happened. Newton said F equals dp dt.
So you don't know what you're.
Let me ask.
Fuck you're talking
no,
about.
you're wrong.
So please
let me check.
shut the fuck up.
Let me check.
Shut the fuck up.
No. Newton never said that.
Shut the fuck up and listen.
No, you're wrong.
Okay.
Newton never
You
said
are
F
not-
equals ma. You don't know that. That never happened. He said F equals dp dt. Did Newton say F equals?
What is dp dt?
Well, it's a change in momentum over change in time. That's not F equals ma.
What is dp dt?
Change in momentum over time. I mean,
What is the integral of dp dt?
The integral of dp dt? I mean, you can integrate dp and you can integrate dt. If you integrate dp, I never integrated dp. Change in.
I'm talking about the second law.
Oh, if you integrate
Newton's
dp,
second
if
law.
you integrate dp, you get p. I mean, the integral of
fucking
dp
moron.
is p.
Okay, now I know that you're a troll.
But anyway, it sounds like you. Anyway, I don't know what you want from my life. I'm trying to. I mean, finally, someone wants to have a discussion about physics, but doesn't want to have a discussion about physics. So, anyway,
Because you
people.
lie.
I'm lying.
You lie and
about.
you don't know what you're talking about.
What do you mean I'm lying?
Okay?
We're having.
If you want to be able to speak to people,
Okay.
this
Stop.
level at least, you need
Okay.
to go
Do me a
get a
favor.
formal education.
Okay. Yeah, I don't want to talk about me. So you want to talk about F equals ma and F equals dp dt?
No. Bye. Bye. Really.
So let me just finish the sentence. So if you want to talk about F equals ma and F equals dp dt and stuff like that, I'll gladly do that. But if you want to talk about me and my education and I need to learn and I need to study, I'm not going to have that discussion.
When I say Newton's law, what
Mhm.
I'm talking about, what I'm trying to describe.
I don't know. I cannot read your mind.
You don't know what are Newton's laws?
I told you F equals dp dt. What do you want me to? What do you want more than that? That's what Newton said. F equals force equals change in momentum.
F equals ma.
No, Newton never
That-
said
that-
that.
It is. Yeah, it
Newton
does.
never said that.
You can say as much as you want, but there's a difference between F equal ma because versus F equal dp over dt. But I'm not sure which one you're stating. Well, so
What do you
which
mean
one
you're
is
not
it?
sure? As far as I know, Newton never said F
He
equals
is
ma.
BSing. He
Anyway,
is BSing.
Exactly. Yeah.
what do you mean I'm BSing? What do you mean I'm BSing? F equals dp/dt, change in momentum over change in time.
Okay.
What?
What is the difference? Okay. So F equal ma versus F equal. Go on.
No, it's not F equals ma. It's F equals
No.
dp/dt.
Okay. So you're Newton now. Is that what you're saying?
What?
F equals ma. That's the second law. But anyway.
No.
So F is not equal to ma.
No, it does, but that's just a special case where
Oh.
you're holding the
What
mass
is the special case?
constant. But what if it's not necessarily the mass is constant. F equals dp/dt is also if the mass is not constant. It's both.
What you just says F is not equal to ma.
I didn't say. I said Newton never said that.
Newton never said that, but you just. Well, hang on. So what is F equal to ma?
F equals ma is a special case of F equals dp/dt where you're holding the mass constant.
Okay, so potato, they're both the same. So which one is it?
What do you mean?
F equal to ma is the second law, but
No, it's not.
the other way around.
No. What do you mean it's the other way?
Do you have any citations? Do you have a paper which can? You just say words, which is lovely, great. But do you have any papers which can say that Newton never said that? That's quite a big, claim, I would say. No. Yes?
I mean, I just heard.
But you just said it was a special case where mass is held constant.
Yes.
But isn't that the general case?
Exactly.
No, the general case is you don't hold constants.
Why? How? Where does that manifest itself? Does mass just like disappear over time?
I mean, yeah, sure. I mean,
how? No. Sure. How? Go on.
No, like in the rocket equation, right? Mass changes.
Well, that's not mass disappearing.
Thank you.
Okay.
Consider something like a ball bearing or a steel sphere, and it's given a large amount of momentum. In other words, it's accelerated to a great speed in a vacuum, and it is traveling along. The force equals ma goes to zero because there's no more acceleration, yet it has a large amount of momentum. So over time, that momentum remains constant. Over time, the mass remains constant. How is that not the general case?
Look, I don't know what you want. I'm just telling you. What's the question? Like, I don't know. What's the purpose of this discussion? You want to talk?
Okay, the question is, how is F equals ma? Why is that a special case of mass being constant instead of the general case of mass being constant? Because even in the rocket equation, the mass is still constant. It has just moved from the rocket fuselage into the atmosphere.
Okay, but what's the point of?
Conservation of mass still holds. Conservation of momentum still holds.
Wait.
I'm just asking what.
This wasn't the point.
Yeah.
The point was, Mr. Slave, you were asking for a question in physics. Then I asked you what is the second law of
Mhm.
Newton.
Mhm.
Then you weren't able to say what it is. Okay, so I asked you, what are Newton's laws? What they help us to describe, and you cannot even say that. Okay, then I proved that you actually don't know what you're talking about, and I helped you to understand that you need to go and study before you talk.
Okay. Don't talk about me. Anyway, you asked me what is Newton's second law of motion. I told you F equals dp/dt, and that's the end of that. I don't know what else you want. I gave you the answer. That's the answer. What's the question?
That's not the end of that. That's not the end of that. Two people now are just telling you. Shubil is telling you. I'm telling you. You say one thing. It's your understanding, but it's not the correct
Let
understanding.
me ask you, can you derive, right? If I say F equals dp/dt, can we derive F equals ma, for example, from F equals dp/dt? What's your opinion?
Sorry, is that from me or
Anyone. I mean, I said F equals dp/dt. Can you
Yes.
derive F equals ma from F equals dp/dt?
So what is the difference between those two? Go on. Sorry, NASA, go.
I'm just asking, can you derive F equals ma from F equals dp/dt? Yes or no?
It's the other way around. You derive F equals dp/dt from F equals ma. You got nothing more than time derivative of the momentum. That's all.
I don't like F equals ma means like I don't know if you can derive.
You still aren't able to explain the second law of motion. Why do we use it and what does it mean? Leave the F equals ma aside. Explain to me what is the second law of motion.
F equals dp/dt. Anyway, I gotta go. See you later. Anyway, these people are complete waste of time. You're not this, you're not that, you're not big enough, you're not tall enough, you're not short enough, you're not. Can you just stress test my theory? No, we cannot stress test. We need to talk about how much you know or you don't know. Oh my God, these people. Wow. Bored.
Well, because of the killing of Israel, instead of thanking the Israelis for getting rid of one of America's number one enemies and somebody with a lot of American blood on his hands, these Democratic congressmen. I closed the window, and I'm not sure AOC was a signature, but I expect she was. Anyway, that is the state of the world in which we live. Let me just see. I want to give an answer to if AOC. Let's see if I can open this tab. One second. This is the state of the left today. That a significant number of them. Yeah, AOC was definitely one of the people who signed the arms embargo on Israel. So it was the entire squad and the supporters. So that's where we stand. That's kind of news from today. Just what happened today, as I said.
And he doesn't want to vote for Trump. So if he votes for Kamala, she's going to embargo Israel.
I'm just continuing. I don't see any updates from Israel in terms of any.
He doesn't see the difference between Kamala and Trump.
Any of those sirens going off in Haifa, any bombs actually dropping. Yeah. So I want to step back a second and let me just say, I think Nasrallah's death is an amazing opportunity. By the way, I didn't mention, I talked about Nasrallah being mourned by Western press, but Nasrallah's death has been celebrated. It's been celebrated in Iran by the people who are against the administration. It's been celebrated in Syria. Syria has been, second only to Israel, maybe even more than Israel, a victim of the Hezbollah, where tens of thousands have been murdered by Nasrallah's people over the years in support of the Syrian regime oppressing its own people, and Hezbollah fighting on the side of the Syrian regime in opposition to the attempt by Syrian opposition figures to overthrow the dictatorship of in Syria. It's been celebrated in Israel. It's I think been celebrated in places like Saudi Arabia and elsewhere. It's been celebrated throughout the Arab world. Generally, anybody believes in civilization, anybody believes in rights and freedom, should be celebrating the death of Nasrallah and hopefully ultimately the complete and utter destruction and dismantling of Hezbollah, a terrorist organization if ever there was one, an evil force in the world stage. So what I want to do now is step back and talk about kind of the context of all this and the history of all of this, and to give you a little bit of sense of how this all plays. The death of Nasrallah will be, it will be a team.
So it's very strange. All he could ask me is the second law of motion. Like I was expecting, ask me something more complicated than GR, quantum mechanics, something serious. No, it was the second law of motion from high school. Let's discuss that.
Moment in Middle East history. It could be a major turning point in the history of the Middle East. Indeed, as I mentioned earlier, Jared Kushner has an essay today, has a Twitter essay, I call it an essay, even though it's not an essay, where he says September 27th is the most important day in the Middle East since the Abraham Accords breakthrough. He's patting himself on the back a little bit there. I'm not sure the Abraham Accords are that important, but he is basically declaring this to be, he says at the end of this essay, this is a new Middle East, this is the beginning of a new Middle East, this is wonderful, this is great, everything's fantastic. And mostly this is a good essay. It's mostly a good essay because he's saying let Israel win, and it's really, really important to let Israel win. But I think here is the key. Nasrallah's death and basically dismantling of much of Hezbollah's capabilities provides Israel and the West with an unprecedented opportunity to remake the Middle East, to completely restructure the Middle East, and to start moving the Middle East towards civilization. Now, the last time the United States had an opportunity like this was after 9/11, and it squandered it. So there's no guarantee that this opportunity will actually be, utilized, would actually be manifest.
No, because to change the Middle East, you have to make it wealthy. To make it wealthy, that's basically impossible. You can't make people wealthy. People don't want to be wealthy. People want to be poor. You tell them you can build a skyscraper. They start crying. The skyscraper is destroying the planet is warming. The planet is warming. The planet is warming. They just want to sit and cry. The planet is warming. They don't want to build skyscrapers. They don't want to live in luxury. No. The planet is burning.
Now, Israel is not the United States, and Israel is in a position right now to do a lot of this. It probably needs the United States help, but not that much help. So, it is.
I mean, Israel should take over the Middle East. That's what it should do, and make it wealthy, at least as wealthy as Israel.
It is here,
which is very poor.
Yeah, it is crucial to understand. We need to understand the Middle East in order to understand why Hezbollah is so important. Hezbollah is a key player here. It's not the most important player, but it's probably the second most important player. The most important player is Iran. I mean, the Middle East has been a place of conflict and a disastrous place for all of history. It's been a place of conflict. It's been a place of war. It's been a place of hatred pretty much forever. But the Middle East got a lot worse. And indeed, global terrorism got a lot worse. On November 4th, 1979, when the American embassy was taken in Tehran, and the United States did nothing. And Ayatollah Khomeini came to power, and Iran basically declared explicitly a global jihad to establish Sharia law over a global empire, And this is what they declared explicitly, and they acted towards this. They started actively funding terrorism throughout the world, Islamic terrorism. They provided massive inspiration to groups like the Muslim Brotherhood that existed beforehand, but had very little success. And with 1979, the Muslim Brotherhood just ballooned in terms of influence. And it's no accident that Sadat was killed just a couple of years later. Sadat had signed a peace agreement with Israel in Egypt and killed by a splinter group out of the Muslim Brotherhood. Al-Qaeda was inspired and created, as inspiration from this global jihad that the Iranians had declared. So they provided inspiration not just to the Shiites. Iran is a Shia. Islam is separated into two major blocks, Sunnis and Shiites who hate each other and be fighting constantly. But the Iranians didn't care whether you were Shiite or Sunni at the end of the day. Indeed, what they cared about was hatred of the West, hatred of everything the West represented, and declaring war on the West. This is exactly what they did. Again, they made this explicit. And they, by doing it explicitly, they told the West what was going to happen, and yet the West ignored them. Reagan cut a deal with them, arms for hostages, if you remember. But immediately, Iran was starting to branch out all over the Middle East and really all over the world. As part of that, in 1983, they sent agents, or 82 really, they sent agents into Lebanon. Lebanon at the time was being occupied, the whole of southern Lebanon, everything from Beirut south was being occupied by Israel. They sent agents to Lebanon to try to recruit from the Shiite population. The Shiite population was relatively small, politically insignificant. The main political power in Lebanon were the Christians and the Sunnis. And as a consequence of that, Hezbollah was founded. It was founded by the Iranians at the time, primarily as a force to try to kick the Israelis out of Lebanon, and then to kick the Americans, the French, the Germans, who had forces, peacekeeping forces in Lebanon. And indeed, the first action was the bombing of an Israeli military base, but then very shortly afterwards, they bombed the Marine barracks, where they killed 241 Marines and about 100 French soldiers. They bombed the American embassy, they bombed other embassies. They basically created havoc in Lebanon and slowly started attacking Israel. And as Israel retreated from Lebanon, which it always intended to leave Lebanon, Hezbollah took the credit for basically pushing Israel out of Lebanon. Then Hezbollah started expanding outside of Lebanon and started attacking Western and Israeli targets in the rest of the world. In 1985, Hezbollah released its first manifesto calling for global jihad, calling for Sharia law on a global scale, the establishment of Sharia law globally and a global revolution, Islamist revolution. Now, in 1989, until 1989, there was kind of a civil war ongoing within Lebanon, even as Israel had occupied big chunks of that. That ended towards the late 80s, early 90s. And Hezbollah gained a real foot in Lebanese politics. By the way, as part of the agreement to end the civil war in Lebanon, Hezbollah, all the militias in Lebanon were ordered to disarm, with the arms going to the Lebanese army, except for Hezbollah. Hezbollah was the only entity allowed to keep its arms. In 1992, the Israeli embassy in Buenos Aires was bombed, an attack attributed to Hezbollah. That year, also, Hassan Nasrallah becomes the leader of Hezbollah after his predecessor is assassinated by Israel. And it also, 1992, is the first year in which Hezbollah wins 8 seats in parliament. It's the first time it starts participating in Lebanese national elections. So it becomes a political force within Lebanon. In 1994, there's a car bombing at Israel's London embassy. And then Buenos Aires Jewish Community Center is bombed. 80 plus people are killed, all attributed to Hezbollah. In 1997, the United States designated Hezbollah a foreign terrorist organization. Not sure exactly why it took it that long, given that the first people who were victims of Hezbollah were Americans in the U.S. embassy. 63 people died, and then another 241 a few days later in the barracks. So, but it took them only 14 years to decide Hezbollah was actually a terrorist organization. But that's typical of American foreign policy. Whether Reagan, whether Bush, whether Clinton, whether doesn't matter, whether Trump, whether anybody. By the way, the bombings of Buenos Aires attributed to Hezbollah and funded by Iran. There's good evidence to suggest that the Argentinian leadership figured out very quickly that the Hezbollah were behind it, and the Iranians basically paid them to stay quiet. And that Kirchner, who was just defeated by Milei, she was the vice president in the previous administration, was indeed received suitcases of cash. And that the prosecutor, the Argentinian prosecutor who was going to bring charges against Iran and Hezbollah, was actually died the day before he was going to, he committed suicide. He was shot and then fell out of the window. No, I mean, he supposedly committed suicide, murdered, the day before he was supposed to provide the evidence to the Argentinian parliament. In 2005, The Lebanese Prime Minister Rafik Hariri, very famous from a very famous Christian family in Lebanon, was assassinated. Again, attributed to Hezbollah. In 2006, Hezbollah entered into Israel and abducted 2 Israeli soldiers, which sparked a month-long war with Israel that left about 1,000 Lebanese and 50 Israelis dead. It was, again, Netanyahu's opportunity to deal with Hezbollah, which he did not do in 2006. It was a failed war. It was considered a real disaster for Israel, even though it was also a disaster for Hezbollah. In 2009, Hezbollah updates its manifesto, where it supposedly expresses more openness to the democratic process. After all, it is participating in elections in Lebanon. It has to position itself as a so-called democratic party. It's trying to appease the West. Never lost its belief in total Sharia law ever, but it needs that in order to gain more seats in the parliament and in order to participate and have power within the political establishment within Lebanon. In 2006, sorry, that was 2009. 2011, Syria descends. If you remember, this is the Arab Spring, part of the Arab Spring. Syria descends into civil war. Hezbollah sends thousands of fighters to support Bashar al-Assad, including and here they're just the most brutal, horrible, unbelievable. What they do to the Syrians. I mean, there's some. You can see some of the numbers are truly astounding of the tens of thousands of people in Syria that they murdered and killed all over Syria, from Aleppo to Hama to Homs in Syria, Nariwan, to the entire border region with Lebanon. All of that was dominated by Hezbollah. Hezbollah massacred, raped, pillaged, starved to death tens of thousands of Syrians. And indeed, Syrian opposition have been celebrating the death of Nasrallah because they actually remember all of this. Anyway, we could go on, but the basic is, in 20, just to give you another sense, 2012, suicide bombing targeted at a bus carrying Israeli tourists in Bulgaria, goes off killing 6 people. European Union blames Hezbollah. 2013.
Okay. Mm-hmm. Mm-hmm. What is this? Who is this? Why is it blue? Why does it have a wrench? Who is that? Channel, go to channel. Oh my god, this is Javier. This is Javier. Like, so he is a mod. So remove managing moderator. No longer managing moderator. Okay, what else we got? Viral worst date ever. Cenk crushes Dennis Prager. Smallest black hole ever suggests a strange anomaly. Mm-hmm. Mm-hmm. Massive drone attack on Russia. Okay. Okay. What else? Okay. You fundrise. I don't know. Okay. I'm just thinking, should we continue? Should we continue along this path? Because I'm so confused already. So I don't know. I feel like maybe we should do a review. We should go back to yesterday's to yesterday's
Hello.
lecture.
Today we're going to start a new series on quantum mechanics concepts, and we're going to start with Dirac notation and its simple application to polarization of photons. Before I start, you are about to see some weird notations, and when I first encountered them, I asked myself two questions, which you yourself might be asking. The first is, why are we using this most bizarre and peculiar form of notation to represent quantum mechanics? And the only answer I think I can come up with is because it works, because it actually spectacularly represents faithfully what you see in experiment, and I'll show you how. The second question I asked myself was, well, given that's the case, who ever thought that this weird form of mathematical representation might conceivably represent the experimental outcomes of quantum mechanics experiments? And the answer to that, I think you have to say is, well, that's the definition of a genius. Only someone who was really brilliant, like Paul Dirac, would have been able to see that you could represent quantum mechanics in this way. So I'm going to begin by starting with the notation and a little bit of the mathematics. For quite a while, we're not going to do any physics at all, whereas we're just going to get our chess pieces out so that we understand what the notation is in mathematical terms, and then we will consider how that is reflected in understanding the physics. So notation and maths first. There is a thing called a ket vector. It is denoted in that way. That is called a ket. There is a associated vector where you'll notice the brackets are the other way round, and that is called a bra vector. I'm afraid Dirac wasn't very creative. The reason he had, which we represent, as I said, by A, can also be represented as a column of numbers. A1, A2, A, for the physics. But in terms of pure notation, on the other hand, a bra, it still has the numbers A1, A2, A3, all the way up to AN, but those numbers are what's called complex conjugated. One the way round is vector numbers. I'll explain what I mean by that in just a moment. On the other hand, a bra vector, which you remember is the other way round, is represented in almost the same way, except that it is a row rather than a column. It still has the numbers A1, A2, A3, all the way up to AN, but those numbers are what's called complex conjugated. And I'll explain exactly what I mean by that. In fact, I better do that now. Firstly, what is a complex number? A complex number, which we sometimes write as z, where an imaginary number is the square root of minus 1. So a complex number consists of a complex number, and what's on a complex plane is we call this the plus iy. That means the value of the imaginary, or x plus I, that is to say, the actual length of this vector, and I'll say squared, is equal to, by Pythagoras, that is simply going to be this squared, which is x squared plus y squared. So the modulus, or in other words, the length of the vector, which is the combination of the real...
Why do you need to say the absolute value? I mean, you're taking the square, so why do you need to take the absolute value?
Plus iy. That's the way we represent it. So z equals x plus iy. And you can see that the modulus of z, that is to say, the actual length of this vector, and I'll say squared, is equal to, by Pythagoras.
So the modulus is the length. Okay.
That is simply going to be this squared, which is x squared plus y squared. So the modulus, or in other words, the length of the vector, which is the combination of the real plus the imaginary part, is simply said by simply given by Pythagoras. Now I mentioned a thing called a complex conjugate, which we denoted by putting an asterisk above the number. That means the complex conjugate of z. And what is this weird thing? Well, it couldn't be simpler. It's simply the same value of x, but you change the sign of the, and you can, I think, you get back to where you started. So the complex conjugate of a complex conjugate is the number you started with. And I can represent this in signs. So now we're going to be at minus y, and consequently the vector z complex conjugate is going to be denoted in that way. You'll notice that the modulus, the length of this vector squared, is still going to be x squared plus y squared, because you're going to get x squared plus minus y all squared, and minus y all squared, of course, is plus x plus. I want to draw your attention to something rather interesting, which is that if you multiply z by its complex conjugate, you're going to get x plus iy multiplied by its complex conjugate x minus iy. And what you're going to get there is x squared. The plus iyx will cancel the minus iyx, and so you're now just going to be left with iy times minus iy, which is minus I squared y squared. But I squared is minus 1. So minus I squared is plus 1, and that will give you plus y squared. The complex number times its complex conjugate gives you the same result as the modulus of that number squared. The modulus of z squared was x squared plus y squared from Pythagoras, but you get the same result if you multiply the number by its complex conjugate. And that will be important when we get to some of the physics of quantum mechanics. I hope you will see that if z is just a real number, e.g. 2, then z star also equals 2, because you only change the imaginary term, the real number, to be. That's going to produce a ket vector, these vectors. So let's say we've got a vector is just the real number. Now we need to consider what happens if we add these vectors. So let's say we've got a vector, this is a ket vector A plus a ket vector B. That's going to produce a ket vector C. And the way it works quite simply, I'm going to use 3 dimensions to save a bit of time. So we're going to have A1, A2, A3 plus B1, B2, B3. What is that going to produce? Well, it couldn't be easier. It's going to be another ket vector, and you simply add the dimension and dimensions. The 2-dimensional ket. Now for vector A, we're going to see that multiplication. Let's say that we're going to take a number, which could be a complex number. Of course, it's easier. So whatever that number, whether it's a real number or a complex number, you simply multiply each of the in physics. And that is what happens if you multiply a bra vector by a ket vector. So we've got bra vector A times ket vector B. That is called an inner product. And it's kind of equivalent to a dot product if we were simply talking about ordinary vectors. And the way you work it out is you write out the bra vector. And you remember I said that the bra vector is a row vector, one vector, but this will be B1, B2, are complex conjugated. Write out the bra vector. And you remember I said that the bra vector is a row vector where all the elements are complex conjugated. And we now know what that means. Multiplied by the ket vector, which of course is a column vector, but this will be B1, B2, B3. And what that produces is not a vector, just a number. And the number is produced by taking the first element in each case and multiplying together, plus the product of the 2 star times B2 plus A is just a number. It is not any that through kind of similarity. What you will get here is B1 star A1 plus B2 star A2 plus B3 star A3, because these will just be reversed. If I now take BA and I complex conjugate it, I will get B1, because the complex conjugate of a complex conjugate gets you back to where you started, times.
What is he doing? This is A times B. This is B times A. So A times B is A1 conjugate B1. Okay, that's all of this. Now B dot A is B is conjugated, and now B dot B times A conjugate. So you're taking this and you're conjugating it. How would you conjugate this? So it's this, but this is a complex number, so it's this conjugated. So it's B1. Why isn't it putting a star? It's a conjugate, no?
A1 star plus B2 times A2 star plus B3 times A3 star. Back to where you. If I now take BA and I complex conjugate it, I will get B1, because.
Okay, so what he's saying.
The complex conjugate of the complex conjugate gets you back to where you started, times A1 star plus B2.
Oh, okay. But he's doing the complex conjugate of B1 star A1. Who says that you can do that? He didn't prove. Did he prove that you can do that? This is 1330. I don't want to waste time looking for questions. How many questions? 752 comments. Everything is from 11 years ago, so nothing is time-stamped. The question is, if you complex conjugate this thing, if you complex conjugate x plus b, is it true that you complex conjugate x and you complex conjugate b? Is that the same? And complex conjugate x times b, is it true that you complex conjugate x times complex conjugate b? I don't know. We need to prove it. Did we prove it? The complex conjugate of a plus b? There's no complex conjugate. There's the complex conjugate. That's just the definition. No. He didn't prove that the complex conjugate of a. See, he skipped a step here. He never proved it. Proving complex conjugate addition.
In this example, we're going to prove some results about complex conjugates. Okay, in this example, we're going to prove some results about complex conjugates. Okay, the first one I'm going to prove is that the Z1 plus Z2, the conjugate of that, because this is just another complex number, in fact equals.
See, he never proved that.
The conjugate of Z1 plus the conjugate of Z2 is separated. Okay, so I can separate the conjugates. Okay, how do we prove this? Well, before we start, I'm going to let Z1 equal X1 plus I Y1. I'll let Z2 equal X2 plus I Y2. Okay, so that means what do we get here? Well, what do we get? If we follow this, okay, we're getting X1 plus I Y1 plus.
Did he say if we A-fy? What do we do?
Well, what do we get? If we follow this, okay, we're getting X1 plus I.
Follow? So Z1 plus Z2, well, this is Z1 and this is Z2, so you just write it out. X1 plus IY1 plus X2 plus IY2.
Y1 plus X2 plus IY2. That's all being
Okay.
put to a
Right. You want to complex conjugate the whole thing. Mm-hmm.
conjugate. Okay, so I'm just following this to here, and then my result will prove this right-hand side. So I should say left-hand side equals.
Okay.
Now, what do we do when we add complex numbers? We've already gone through that. We add the real values together.
Very good. So you can put the x1, x2 together, and I times y1 plus y2 together.
And we add the imaginary values. I'm just going to factor out the I. Okay, that's still having a
Mm-hmm.
bar above it. This is just another complex number. Okay.
Yeah, it's just a complex number. So it's real plus imaginary. So what's the conjugate of this? It's this minus that.
So we take the conjugate of this complex number. Imagine this x1 plus x2, we get some value. Y1 plus y2, we get some value. And that's the complex number. We take the conjugate, all that happens is this turns into a minus. So we end up getting x1 plus x2 minus
I times
y1 plus
y1.
y2.
Mhm.
Now, notice what we get here. We get x1 plus x2.
So now we're gonna break it up again. So x1 plus x2 minus I. He's gonna write out the I times y1 plus I times y2.
2 minus iy1 minus iy2.
Right, and now he's gonna say x1 minus iy1 plus x2 minus, which are the two conjugates. Yeah.
We end up getting x1 minus iy1, okay, plus x2 minus iy2.
I was going to put parentheses and declare that this is Z1 and Z2.
What does that mean? Well, look at Z1, look what we have here. That's the conjugate of Z1, and that's the conjugate of Z2, which in fact equals the right-hand side. So we've proven that, okay? If you have any problems with explanations, just shoot me an email and I'll reply and I'll happily explain what has happened, okay? The next one we want to prove,
Multiplication.
okay, is Z1 minus Z2. And we want to prove that that equals this, okay?
You really need to prove it separately?
So same sort of thing, okay? The left-hand side, well, let Z1 equal X1 plus Y1, so I'm going to write that. So X1 plus IY1, okay? This time I'm subtracting from
It's good for me to see this math so that my brain gets used to doing complex conjugates, as simple as they are.
X2 plus IY2, okay? That's all being put.
So he didn't define Z1, he's just writing, it's like above. So Z1 and Z2, okay. So we're going to go through the same steps.
Above. So what do we do? We simply subtract it, X1 minus X2, okay? I'm going to put a plus sign, Y1 minus Y2, okay? So this turns into a...
Okay. Right, so he's doing that. The next step is to put the complex conjugate, make it a minus in the middle.
Positive, sorry, negative. Okay, same as the last example.
Once you do that, well, now you need the line for the complex.
So we end up getting...
You didn't do the complex conjugate line. You need to still do the complex conjugate line, but the complex conjugate is plus.
Is X1 minus X2 minus IY1 plus IY2.
Oh, he didn't. Oh, sorry. Okay. So it's X1. X1 minus IY1 and X minus X2.
So we get X1 minus IY1, okay, plus minus X2 plus IY2.
Okay, this is what, well, you don't want the minus there, do you? You never want that. You want to change the minus.
We factor out negative, we get X1 minus IY1, okay, minus X2 minus IY2.
Right. So what you have here is the complex conjugate of Z1 minus the complex conjugate of Z2 Right, this is Z1 and Z2. And that's what we wanted to prove.
Which in fact equals Z bar 1 minus Z bar 2. Okay. In the next video, I'm going to prove the multiplication and I'm going to prove the division. So they're a little bit more complex. Okay.
Dr. How long ago? 10 years ago.
Okay, in this example, we're going to evaluate this question, and it's saying if Z1 equals 2 minus 3i and Z2 equals 1 plus 4i, we want to evaluate Z1 plus Z2, Z1 minus Z2, Z1 Z2, and Z2 divided by Z1. Okay, so for the first one, we are... Okay, in this example, we're going to prove some...
I want to... Okay, operation... What... proving complex conjugate addition. Let's just write here multiplication.
Okay, welcome back to another example of proving complex conjugates. So in this one, we're going to prove that Z1 times Z2 its conjugate equals the conjugate of Z1 times conjugate of Z2. So just basically separating conjugates. Remember what we did in the other...
So Z1 times Z2 complex conjugate is Z1 complex conjugate times Z2 complex conjugate.
Example, we let Z1 equal X1 plus I Y1, and we let Z2 equal X2 plus I Y2. So the left-hand side, so we're going to follow this, and we're going to prove it equals this. The left-hand side equals X plus...
Right, so it's X1 plus I Y1 times X2. Wow, this is going to be complicated because you have multiplication.
I Y1, sorry, X1 plus I Y1. That's being multiplied by X2 plus I Y2.
So you need to multiply, well, and put the line on top.
Or being put to the conjugate.
Okay, so now
okay.
The next step is to multiply this out.
That equals, if we expand this, we get X.
Expand. So X1 times X2 and X1, plus X1 times IY2.
X1, X2 plus X1, IY2 plus IY1, X2 plus I squared Y1, Y2. Or having a bar above it.
Okay. Wow. How are you going to deal with that? Separate the i's. You have I squared. You can get rid of that. So that's negative. So Y1, Y2. So it's X1 times X2 plus, minus Y1 times Y2. And this one has i's.
This actually simplifies down to, okay, the I squared becomes a negative, okay? And I'm going to group my imaginary parts and my real parts because this becomes a negative 1. So this becomes a real part, and I'm going to group all the X1, X2. So X1, X2 minus Y1, Y2. That's from here.
That's the real part. Now, these guys, so you take the I out. It's X1, Y2 plus Y1, X2.
Plus, going to factor the I out.
Times.
Okay, X1, Y2.
Which is just a complex. This is just a complex number.
2 plus X2 I1.
Conjugate.
A bar above it.
So now the conjugate is just put a minus there.
Yeah, this is just a complex number. Okay, if we find the conjugate of this complex number, it actually just turns into a minus. Okay, now.
That's it. The next step is to spread this out, right? Because you want to prove it's Z1. I think the next step would be to actually do this and show that you get the same result. That's what I would do. Like, otherwise, what else can you do? Z1 conjugate, can you pull Z1 conjugate from this thing? I don't know. I would never know how to do that.
This does, in fact, equal the conjugate of Z1 times the conjugate of Z2, this part here. And
it is? Well, you need to do it.
Which equals the right-hand side. And you can prove that if you go and prove the right-hand side. If I take this...
Yeah, he has to take the right-hand side.
The conjugate of Z1, which is...
The conjugate of Z1 is X1 minus IY1.
X1 minus IY1. And
multiply by X2 plus minus IY2.
Multiply with X2 minus IY2.
So now you need... So you claim that this is this.
You in fact get this. Okay.
Move your pen, please.
So that means that equals that.
Move
So
your
this
pen.
is and A equals right here.
Move your pen.
It's like, so you've proven this.
Move your
complex conjugate.
pen.
Okay. Next video I'm going to look at is division.
Oh my god, he didn't move his pen.
Okay, welcome back to another example of proving complex conjugates. So in this one, I'm going to prove that Z1 times Z2 is conjugate equals, if I take X1 by Y1, 2, you will in fact get this. Okay.
As soon as he writes it, he hides it. He doesn't wait. He just finished writing it and already
X1
he's hiding
minus
it.
IY1, and I multiply with X2 minus IY2. You will
See, he doesn't wait. He doesn't give you a chance.
2.
Doesn't give you a chance. Hopeless. There it is. Okay. So x1 times x2 is this. And then the end is negative iy1, negative iy2. And negative is positive. I is negative, so it's minus y1, y2. That's good. And the I is negative iy1, negative I y1 x2, and positive no, it's also negative x1 I y2. Yeah, correct. So it's correct. Okay, so we proved complex conjugate multiplication.
Result. The same result if you multiply the number by its complex conjugate. And that will be important. Then Z term. If you don't have any imaginary term, if we add these vectors, and the way it works quite simply, I'm going to use B3, first term in the ket vector. So this is one whole number because in number of dimensions. It's no use to choose 3 for a number. Multiplied by the times, well, A, again, I can represent them to give you a new ket vector, like each of the individual terms, and that is what happens if an inner product. And it's kind of equivalent to a dot product if we were simply a row vector, column vector, but this will be B1, B2, B3. And what that puts together, then adding the product of the second elements times B2 plus, it is just a number. It is not, we'll see that through 3 star complex conjugated, I star plus B, so we've just shown that. Now I must introduce you to a matrix. We're still doing the maths here. We haven't gotten to any physics yet. I'm going to introduce you to a matrix. It's a square matrix. It can have any dimensions, but I'm going to choose 3 dimensions simply to make life easier. And a matrix you write with curly brackets, and it will have a row and a column. The rows are easier.
Where
I'm going to introduce you to a matrix. A, B is the same as that.
So we wanted to
3 star A3 because these will just be reversed. If I now take BA and I complex conjugate,
B times A complex conjugate. So we already proved that, I think it's the distributive property and the multiplicative, whatever. Anyway, we can spread out the conjugate the complex conjugate attribute. So it's the same as this, just opposite. Because to take the complex conjugate of this, we know that the complex conjugate of a number is the complex conjugate of each of the parts. And the complex number and the complex conjugate of a product is the complex conjugate of one of the numbers times the complex conjugate of the other. And we know that the complex conjugate of a complex conjugate is the number. We proved that.
I will get B1 because the complex conjugate of a complex conjugate gets you back to where you started, times A1 star plus B2 times A2 star plus B3 times A3 star. But that is the same as that.
So AB is equal to BA complex conjugate. Because this is A1 star B1, A1 star B1, A2 star B2, A3 star B3. So yeah, so the complex conjugates are the same. So AB is BA complex conjugate.
Because the order of the numbers doesn't matter. And so we've just shown that AB is equal to BA.
BA complex conjugate.
Complex conjugated. Now I must introduce you to a matrix. We're still doing the maths here. We haven't gotten to any physics yet. I'm going to introduce you to a matrix. It's a square matrix. It can have any dimensions, but I'm going to choose 3 dimensions simply to make life easier. And a matrix you write with curly brackets, and it will have a row and a column. The rows M11, M12, M13. The second row M21, M22, M23, and the third row.
Let me see if there's anyone alive. I'm giving up on this server. This is such a terrible server. I mean, everyone here is just so terrible. Let me see if anybody is alive. Like, I haven't spoken to any of my friends. So misinformation, I don't care about him. Stace, let me try her. Wait, are you human? Which object would push the scale down? Click on it. A pear or a fly? Which object would push the scale down? This one. Okay. Mima. You can't hide from... I don't know. Is he a good guy or a bad guy? I don't know. Mordwand. Is this Sea Lion? I think this is Sea Lion. Mordwand. Brian. NASA Shill. Karen. NASA Shill. Judas is already sleeping. Spaghetti, I don't know. Cena sleeping. Zarmar. Amber. Push the scale down. So Amber. Andrew's sleeping. Judas is sleeping. That's it. There's no one else.
Live. I want to ask him the question on the thing where people hear it and they hear whatever his answer is. His answer is going to be his problem. And then I'm going to say, okay, what are the odds that the Earth isn't a globe? You know, you heard these crazy flat earthers before? He's going to laugh and say, 1,000,000 to 1. You know, and I'm going to say, well, I'll take that bet. Now, how are you going to prove physically right here on the ground that the Earth's a globe? How would you do
Isn't he
that?
the worst
Elon?
person isn't he the worst person to bet, dude? He just
No,
put
he
a
owns
camera.
he owns
He just put a
3
camera on
rockets.
one of his rockets, dude.
No, he's not the worst person to bet because my helium balloon is going to outdo his rocket. So he's the guaranteed one I want to bet with his little puny rocket. Yes, sir.
There is also one other reason why he's the worst person to bet, and that it's because one of the things implied on a typical bet is that one person or mutually the other person has enough money to put up that the other person would be interested in receiving, and Elon Musk isn't interested in winning anyone else's money. He has enough himself. It's like, why would I bet you? Do you think I actually need the money that I would win from the bet?
No, but I want to put it out there that a balloon will rise in altitude faster than any rocket he could ever make or think of horizontally.
You'd have to paint the picture to put his honor on the line of the bet, and you'd have to build your pitch for him to be willing to do it where it's actually like a threat of disgracing his honor to kind of goat him into doing it.
That's why I was starting with him, talking to him, and asking him about flat Earth, or whatever or something, or talking for a second, and then put it in there. What are the odds?
Oh my God. Let's go back to him.
2013, this is 30 years after the bombing of the U.S. Embassy. The EU designates Hezbollah ongoing, not the entire organization, a terrorist organization, after considerable debate among the bloc members. They're not quite sure. In 2019, Israel discovers miles of tunnels into Israel from southern Lebanon, and it says belongs to Hezbollah. Another opportunity Bibi Netanyahu had to destroy Hezbollah. Nothing really was done. The tunnels were blocked, but nothing more than that. In 2019, there are massive demonstrations in Lebanon against Hezbollah and the rest of the political establishment in Lebanon because of economic problems. Nothing really changes. Lebanon is in grave economic damage. And then, of course, we know September 8th, in support of Hamas, Hezbollah launches rockets against Israel. And I'm skipping over the many other atrocities that Hezbollah has committed over many years. Now, this all fits into a broader narrative, and that is fundamentally the narrative of Iran. So Iran is I think,
1 second.
in the 1980s, it fights a war with Iraq. About 1 million people die in that war. It's basically fought to stalemate. They can't beat the Iraqis. This is to suggest how strong the Iranian military is. They couldn't even beat.
I think I'm going to stop here. 1 second. Oh, Amber. I can't tonight. Okay. How long? We've been here for 3.5 hours. Yeah. I want to continue, but I want to eat something maybe. I'm thinking, should I eat? Yeah, I need to eat. I'll eat something. Okay, I'll come back. Bye.